해수면이 높아져 출입을 통제하는 날짜가 갈수록 늘고 있는 탓에 대한민국 기후변화 1번지라 불리기에 이르렀습니다. 대한민국에서 제주가 기후변화에 가장 발빠른 움직임을 보일 수 있었던 이유는 자연이 주는 이 묵직한 경고음을 가장 가까이에서 보고 들었기 때문일지 모릅니다. 세계 유일의 유네스코 자연과학 분야 3관왕 제주는 대한민국을 넘어 전 세계가 지켜가야 할 천혜의 섬입니다. 2007년 세계 자연유산으로 등재된 제주는 2010년 국내 최초로 유네스코 세계지질공원에 지정됐습니다. 2002년 처음 선정된 생물권 보전지역은 2019년 보전 범위가 섬 전체로 확대됐습니다. 대한민국을 대표하는 글로벌 환경 브랜드 제주는 탄소 중립선 프로젝트 CFI 2030을 지난 2012년부터 꾸준히 업그레이드해 한국판 그린 뉴딜을 선도하고 있습니다. 콥28의 제주 유치는 기후변화 협약을 선도하고 있는 대한민국의 모범 사례를 전 세계에 각인시키는 가장 확실한 방법이 될 것입니다. 콥28은 세계 최대 규모의 국제환경회의입니다. 글로벌 스탠다드를 충족하는 인프라가 완벽히 구축돼 있어야 하는 이유입니다. 세계자연보전총회 등 다수의 정상급 대형 국제회의를 개최한 제주국제컨벤션센터는 2023년 개관 예정인 제2센터를 포함 2만여 명이 참여하는 콥28 행사에 최적화된 공간이 될 것입니다. 더 나아가 제주국제컨벤션센터에서 차량 5분 이내에 2,000여 개의 객실은 물론 다양한 형태의 중저가 및 고급 숙박시설도 차량 20분 이내 지역에 위치해 있습니다. 콥28이 요구하는 인프라를 모두 충족하는 대한민국 단 하나의 지역이 바로 제주인 것입니다. 대한민국 기후변화의 최전선, 콥28 개최의 최적지. 이곳의 이름은 제주입니다. 한라산 병풍바위를 지나 윗세오름을 향하다 보면 짙푸른 바늘잎의 구상나무 군락을 만납니다. 우리나라 고유식물인 이 나무의 이름, 구상은 성게를 뜻하는 제주도 방언 쿠살에서 유래했습니다. 이 나무의 개량종은 해외에서 크리스마스 트리로 널리 쓰이지만 정작 제주에선 급격한 기후변화로 인해 구상나무가 점점 사라지고 있습니다. 제주는 대한민국에서 기후변화에 가장 큰 영향을 받는 땅입니다. 한라산에선 고산식물이 점차 사라지고 따뜻한 곳에서 더 잘 자라는 소나무가 늘고 있습니다. 용머리 해안은 해수면이 높아져 출입을 통제하는 날짜가 갈수록 늘고 있는 탓에 대한민국 기후변화 1번지라 불리기에 이르렀습니다. 대한민국에서 제주가 기후변화에 가장 발빠른 움직임을 보일 수 있었던 이유는 자연이 주는 이 묵직한 경고음을 가장 가까이에서 보고 들었기 때문일지 모릅니다. 세계 유일의 유네스코 자연과학 분야 3관왕 제주는 대한민국을 넘어 전 세계가 지켜가야 할 천혜의 섬입니다. 2007년 세계 자연유산으로 등재된 제주는 2010년 국내 최초로 유네스코 세계지질공원에 지정됐습니다. 2002년 처음 선정된 생물권 보전지역은 2019년 보전 범위가 섬 전체로 확대됐습니다. 대한민국을 대표하는 글로벌 환경 브랜드 제주는 탄소 중립선 프로젝트 CFI 2030을 지난 2012년부터 꾸준히 업그레이드해 한국판 그린 뉴딜을 선도하고 있습니다. 콥28의 제주 유치는 기후변화 협약을 선도하고 있는 대한민국의 모범 사례를 전 세계에 각인시키는 가장 확실한 방법이 될 것입니다. 콥28은 세계 최대 규모의 국제환경회의입니다. 글로벌 스탠다드를 충족하는 인프라가 완벽히 구축돼 있어야 하는 이유입니다. 세계 자연보전총회 등 다수의 정상급 대형 국제회의를 개최한 제주국제컨벤션센터는 2023년 개관 예정인 제2센터를 포함 2만여 명이 참여하는 콥28 행사에 최적화된 공간이 될 것입니다. 더 나아가 제주국제컨벤션센터에서 차량 5분 이내에 2,000여 개의 객실은 물론 다양한 형태의 중저가 및 고급 숙박시설도 차량 20분 이내 지역에 위치해 있습니다. 콥28이 요구하는 인프라를 모두 충족하는 대한민국 단 하나의 지역이 바로 제주인 것입니다. 대한민국 기후변화의 최전선, 콥28 개최의 최적지. 이곳의 이름은 제주입니다. 한라산 병풍바위를 지나 윗세오름을 향하다 보면 지푸른 바늘잎의 구상나무 군락을 만납니다. 우리나라 고유식물인 이 나무의 이름, 구상은 성게를 뜻하는 제주도 방언 쿠살에서 유래했습니다. 이 나무의 개량종은 해외에서 크리스마스 트리로 널리 쓰이지만 정작 제주에선 급격한 기후변화로 인해 구상나무가 점점 사라지고 있습니다. 제주는 대한민국에서 기후변화에 가장 큰 영향을 받는 땅입니다. 한라산에선 고산식물이 점차 사라지고 따뜻한 곳에서 더 잘 자라는 소나무가 늘고 있습니다. 용머리 해안은 해수면이 높아져 출입을 통제하는 날짜가 갈수록 늘고 있는 탓에 대한민국 기후변화 1번지라 불리기에 이르렀습니다. 대한민국에서 제주가 기후변화에 가장 발빠른 움직임을 보일 수 있었던 이유는 자연이 주는 이 묵직한 경고음을 가장 가까이에서 보고 들었기 때문일지 모릅니다. 세계 유일의 유네스코 자연과학 분야 3관왕 제주는 대한민국을 넘어 전 세계가 지켜가야 할 천혜의 섬입니다. 2007년 세계 자연유산으로 등재된 제주는 2010년 국내 최초로 유네스코 세계지질공원에 지정됐습니다. 2002년 처음 선정된 생물권 보전지역은 2019년 보전 범위가 섬 전체로 확대됐습니다. 대한민국을 대표하는 글로벌 환경 브랜드 제주는 탄소 중립성 프로젝트 CFI 2030을 지난 2012년부터 꾸준히 업그레이드해 한국판 그린 뉴딜을 선도하고 있습니다. 콥28의 제주 유치는 기후변화 협약을 선도하고 있는 대한민국의 모범 사례를 전 세계에 각인시키는 가장 확실한 방법이 될 것입니다. 콥28은 세계 최대 규모의 국제환경회의입니다. 글로벌 스탠다드를 충족하는 인프라가 완벽히 구축돼 있어야 하는 이유입니다. 세계 자연보전총회 등 다수의 정상급 대형 국제회의를 개최한 제주국제컨벤션센터는 2023년 개관 예정인 제2센터를 포함 2만여 명이 참여하는 콥28 행사에 최적화된 공간이 될 것입니다. 더 나아가 제주국제컨벤션센터에서 차량 5분 이내에 2,000여 개의 객실은 물론 다양한 형태의 중저가 및 고급 숙박시설도 차량 20분 이내 지역에 위치해 있습니다. 콥28이 요구하는 인프라를 모두 충족하는 대한민국 단 하나의 지역이 바로 제주인 것입니다. 대한민국 기후변화의 최전선, 콥28 개최의 최적지. 이곳의 이름은 제주입니다. 한라산 병풍바위를 지나 윗세오름을 향하다 보면 지푸른 바늘잎의 구상나무 군락을 만납니다. 우리나라 고유식물인 이 나무의 이름, 구상은 성게를 뜻하는 제주도 방언 쿠살에서 유래했습니다. 이 나무의 계량종은 해외에서 크리스마스 트리로 널리 쓰이지만 정작 제주에선 급격한 기후변화로 인해 구상나무가 점점 사라지고 있습니다. 제주는 대한민국에서 기후변화에 가장 큰 영향을 받는 땅입니다. 한라산에선 고산식물이 점차 사라지고 따뜻한 곳에서
8시 됐습니다. 네. Are we ready? Okay, I don't see any screen on my laptop yet, but I think it's time to start. This is the first day of 3rd Silicon Valley Business Forum in consortium with the 8th International Electric Vehicle Expo. Welcome, everyone. Good morning to everyone in Jeju Island, and good afternoon out in San Francisco area. And this is a beautiful day. I don't know how it is out in San Francisco, but in Jeju Island, the weather itself is great. After all those hot summer days, we have finally nice breeze, high skies, and wonderful weather temperatures and whatnot. As you all know that we have a great two keynote speeches prepared for today's event, and I am really excited to introduce them as it comes the time. And my name is Dan Ung-chol Choi, working at the Department of Automotive Engineering, Kookmin University in Seoul, Korea. And without further delay, I would like to welcome Chairman K.H. Moon to give us a opening remarks for today's event. Please welcome Dr. Moon.
넘기는 걸 누가 가져가셨네.
Can I have my clicker?
Korea. Good afternoon, Silicon Valley. 여러분 안녕하십니까?
Good morning and good afternoon, everyone. Welcome to the Silicon Valley Business Forum. This year marks the 3rd anniversary of the SVBF, and if we include Roundtable, it actually is our 5th time to host such events. 4 or 5 years back, on the occasion of the IEVE, we thought how we can vitalize this expo and expand its linkage with the economy sector, so that we can make IEVE a more global event, just like World Economic Forum. So I asked Chairman to make this happen, and 1 and 2 years ago, the Chairman gave us a congratulatory speech, and he's also serving as the advisory role for the IEVE as well. And 2 years back, we made a good preparation to give birth to the SVBF. However, due to COVID-19, we could not make it happen online, but we have been hosting this event online and offline 2 times. In July, we conducted such events. And in conjunction with the IEVE, we are hosting this 3rd SVBF, or Silicon Valley Business Forum. So I would like to thank Chairman Kim Dae-hwan from the IEVE Organization Committee and many other entrepreneurs and venture capital companies and professors who are gracing this event and making this event possible. Once again, the Silicon Valley Business Forum was supposed to be linked with the Korean EV providers, but our ultimate goal is to provide more startup opportunities for Asian players and also instill entrepreneurship and the motivation for innovation. This is part of our ways to respond to climate change. So the map of the Silicon Valley Business Forum, the scope of it is very big. The United States and the China and Korea is forming an economic realm, and the fourth economic realm or area would be Silicon Valley Business. This fourth scope of the Silicon Valley Business Forum starts from Canada to go to Korea, and to the left, it links the Middle East and North Africa region as well. We are trying to tap into the MENA and encompass both advanced and developing countries to create a network of $23 trillion, or if we include Japan, even $28 trillion. So the FBBF has a great potential. And in terms of doing so, we are always considering the SDG goals. 17 goals of the SDGs matter all, but we picked some of the SDG goals to primarily focus on, and most of them are related to the environment sector. So in terms of renewable energy, we thought that the Silicon Valley Business Forum and the IEVE should work together, and also in the field of the EV cars and the battery. That is why we have been conducting this event for the third time in conjunction with the IEVE. And the second pillar of our SVBF is people sector, which include vaccine development or the genomics and many medicine-related technology development. So in the second pillar, we are trying to focus on the health and biosector. And about this, along with the National Life Sciences Institute of Korea, we have hosted such events in Daejeon, Korea. And the third pillar is focusing on economy. With the technologies related to fourth industrial revolution, we are trying to focus on 18 industrial sectors. To provide tailored support to these 18 industries, we need great industry ecosystem, and universities should assume a larger role. That is why I focus on the third pillar. And in the third pillar, we invest in people so that they can drive the new economy forward. And it is my great privilege to have this special session that will discuss the specific structure of this FBBF tomorrow. Once again, I thank you for the support. Fortunately, the entire world agreed to co-respond to climate change, and the world seemed to be on the same track, but we lost 5 years while we were doing so on our journey towards UN SDG goals. But now the United States is once again back on the journey toward SDGs. The renewable car in the EV car industry and battery industry is being aided a lot in this, with United States joining back on track. Indeed, the new investment coming to the United States, focusing on EV cars or the battery cars, amounts to $4 million. So in that, I would say the primary goal of the SVBF is sort of met. With $40 billion, we can create an immense ecosystem, be it materials or the parts and the service sector and whatnot. We can create diverse and vibrant ecosystem centering around battery and autonomous vehicles. And EV cars not at the sideline anymore. It is already a mainstream trend. Some countries are saying that starting from the 2025, we can say goodbye to the ICE cars. Although many countries are still seeing 2030 to be the year of saying goodbye to ICE cars. But still, this is a good movement in that we are moving forward in abiding by the agreement that we made in terms of environment. When it comes to the battery and EV car markets, it is 3 trillion or 4 trillion won worth of market. Given that the GDP of the entire Korea is 1.7 trillion won, the market size of 3 trillion or 4 trillion dollar by 2040 is such an immense number. Then what's next? It is time for us to wait for the arrival of the autonomous vehicles. Many are still suspicious of the battery-powered cars, but despite many people's suspicion, we are moving beyond hybrid cars and going into the BEV cars actually. And now we see a lot of suspicions toward autonomous vehicles. Many global companies indeed stopped working in this field, but recently we're seeing a new impetus behind the autonomous vehicles. So we have to once again look at the autonomous vehicles and try to discuss its future. And in line with that, what kind of preparations are made in the field of smart cities? When it comes to Korea, we're lagging behind in terms of smart cities with a global ranking of 47th place to 50th place. So we're gonna have to talk about these areas. And we have invited CEO Maha Ashur, a great expert in these fields. Ms. Maha Ashur is 50 Vision over 50. And she's one of the top 5 global renowned experts in terms of autonomous vehicles. And along with her, we also have invited renowned experts and figures, for example, from Alice Technologies. And tomorrow, we're going to discuss the topic of startup ecosystems. Chairman Osama, 3 years back, along with the Professor Han Jung-hwa, gave a big thought and deep thought on the topic of startup ecosystem. And the result of this year-long studying has been out. So we want to dig deeper into this topic and see what has been changed for the last 3 years. We would like to see who can play the role of overseas startup ecosystem players in Korea and how good Korea is doing when it comes to startup accelerator and the angel investor and so on and so forth. I'm a part of the venture capital ecosystem, and Chairman Go Young-ha is actually one of the noted angel investors in Korea, and his dream was to create 1,000 unicorns in Korea by 2030, and I am sure that we can make this dream come true. We have Dr. Osama Hassanein present here, and we also have CEO Han Jung-hwa from Asan Nanon Foundation and Chairman Go Young-ha and many other professors from universities and presidents from universities. If you work together and if you set your volition on making this happen, I believe that we can create 1,000 unicorns by 2030 for sure. This can translate to $1.0 trillion in Korean market. I do hope that this dream of enormous number of unicorns in Korea come true. And with that, I would like to conclude my speech. Thank you.
Thank you. I forgot to mention that today's event is serviced in 2 different languages. One naturally Korean, the other one is English. And if you look at the screen, towards the bottom of your screen, you should be able to select the languages of your choice. All right, so I just want to remind that. And our next congratulatory remarks is by Chairman Tae-hwan Kim. He is the chair of the 8th International Electric Vehicle Expo. Please welcome Chairman Tae-hwan Kim.
이 자리
This wouldn't be possible without any effort and dedication by Chairman and President Moon Guk-hyun, and I appreciate for his effort. Face-to-face and non-face-to-face events are mostly being cancelled. Nevertheless, President Moon, Chairman Moon always devoted himself to host such wonderful events. And with everyone's effort, we're gathered by all our global family of the International Electric Vehicle Expo. Once again, I would like to thank all for participating. As a family of e-vehicle around the globe, this will be a great opportunity to discuss various issues, and thanks again for your participation, and I hope you have a very joyful and fruitful time from today and tomorrow. We are hosting this event offline in Jeju, and along with all our family in 50 countries, we are together online and offline, and I think this is a great implication for us regarding how the future will go. UAM and e-vessel, as well as new materials, carbon and nano materials, are added as a new topic for this year's Expo, and you can fully feel the changes in the industry. Once again, Chairman Moon Guk-hyun and Dr. Osama, thank you very much. And then once COVID gets eased, I hope to see you again in person. Thank you.
Okay, we have a little change in schedule. We're supposed to have Dr. Osama Hassanain's welcome remarks. However, he has a doctor's appointment for little reason, but not that light. So we have another principal in the Rising Tide Fund, Dr. Brent McDonald, to give us the welcome remarks. And towards the end of the speech, we will welcome Dr. Renee Morcus from Alice Technology to finish up the presentation. Please welcome Dr. Brent McDonald.
Well, thank you to each and every one of you. We are very pleased to be able to welcome those of you that have been with us before or are new to the Silicon Valley Business Forum. The aim of today's virtual event is to highlight innovation created by impactful individuals and groups leading successful and sustainable enterprises. Our goal is to facilitate the conversations, the collaborations, and the ongoing learning that will not only be enlightening, but provide the impetus for organizations to create cooperative, impactful, scalable, and agile digital enterprises. Our agenda highlights companies and teams excelling in rising target markets and leaders whose unwavering focus is on fundamental technology breakthroughs. So let's begin. The title of today's presentation is The March Towards Sustainability in Smart Cities. I also have the privilege to be joined by Dr. Renee Marcos, founder and CEO of Alice Technologies. Alice Technologies is an AI-powered construction simulation and optimization platform that helps companies easily create, explore, and update construction schedules that reduce risk while cutting construction costs. Founded in 2015 and based on research from Stanford University, Alice Technology works with construction leaders in the infrastructure, industrial, and commercial construction segments. Dr. Marcos will elaborate how Alice Technology is enabling smart and sustainable cities. So what is the main goal of sustainable cities and communities? Many cities safe and sustainable means ensuring access to safe and affordable housing, upgrading underserved settlements. It also involves investment in public transport, creating green public spaces, and improving urban planning and management in a way that is both participatory and inclusive. The United Nations Sustainability Development Goal, number 11, reflects these lofty aspirations. The topics that we'll touch on today include cities on the move, a twin strategy that strengthens competitiveness, and companies around the world that are increasingly focused on their sustainability agenda. Today, the global population is on the move. According to the United Nations, more than 2/3 of the world's citizens will live in cities by 2050, with 90% of this urban growth taking place in Asia and Africa. Given this massive migration to urban areas, the subject of sustainability and sustainable cities is, of course, top of mind for many. Governments, NGOs, corporations, and global leaders worldwide are all involved in grappling with fundamental issues, such as how can mega cities of tomorrow provide essential services such as clean water and adequate waste removal? How can they create a transportation and building infrastructure that reduces the emission of pollutants into the air while taking in so many new residents? As population epicenters, cities consume over 2/3 of the world's energy and account for more than 70% of global CO2 emissions. This number will only grow as escalating urban populations demand and use of more energy for heating, for cooling, for transportation. Energy-related CO2 emissions from buildings, for example, have also risen in recent years. Direct and indirect emissions from electricity and commercial heat used in buildings rose to 10 gigatons of CO2 in 2019, the highest level ever recorded. Several factors have contributed to this rise, include growing energy demand for heating and cooling with rising air conditioner ownership and extreme weather events. Dr. Marcos will address in more detail investments in sustainable building during his presentation. Plans were unveiled last week for Tolosa, a sustainable metropolis created from scratch in the American desert. The ambitious 150,000-acre proposal promises eco-friendly architecture, sustainable energy production, and purportedly drought-resistant water system. The announcement was accompanied by a series of digital renderings and show residential buildings covered with greenery and imagine residents enjoying the abundant open space. With fossil fuel-powered vehicles banned in the city, autonomous vehicles are pictured traveling down sunlit alongside scooters and pedestrians. Another image depicts a proposed skyscraper, which is described as the beacon for the city. The building features elevated water storage and aerophonic farms, an energy-producing photovoltaic roof that allows it to share and distribute all it produces. In addition to an innovative urban design, the project also promises transparent governance and what is called the new model for society. Taking its name from the ancient Greek word telos, a term used by the philosopher Aristotle to describe an inherent or higher purpose, the city will allow residents to participate in the decision-making and budgeting process. A community endowment will meanwhile offer residents shared ownership of the land. It's important to take a step back and witness a profound change in climate action over the past decade. Local government action and ambition has increased, and national governments have also stepped up. In many countries, city targets are more ambitious than their national government commitments. The signing of the Paris Agreement in 2015 was a turning point for city action. Today, the number of cities highlighting their sustainability efforts has more than doubled, showing that smart cities are stepping up to the challenge of cutting emissions. Many cities around the world are already working with the private sector on sustainability projects or plan to do so in the next 2 years. A report by the CDP, an entity that runs the global disclosure system for investors, companies, cities, states, and regions to manage their environmental impacts, reveals that good progress in disclosure and action over the last decade. CDP data reveals that progress in city action and ambition. More and more cities are measuring their emissions and seeing citywide targets. Cities are building resilience against climate threats, taking a total of 3,417 actions, ranging from tree planting and greening, 20% of the cities, to developing hazard-resistant infrastructure, 10% of the cities. And as you can see from this slide, cities disclosing through the CDP data are already outperforming on urgently needed decarbonization compared to the global average. 42% of their energy mix comes from renewable sources compared to 26% of the global average.
Brent,
Yes.
I am just seeing some messages that show slides that I'm not sure if only we can see. I can see the slides clearly, and I don't know if I'm disturbing, but I don't know if the attendees can see the slides. So I'm just letting you know that.
Okay, great. I have, it says I am sharing. So I presume people can see.
I think it's not full screen, so that might be why.
Ah.
There's two attendees that asked to show the slides.
Brian,
So I thought,
Brian, I can see your face very nice and clean, but I don't really see the screen of the presentation material itself.
Okay.
Maybe it's been flipped. Are you using dual monitor system?
No.
No?
Okay. Let me try a few functions. I'll see if I can.
Yeah, take your time.
Sure.
It's actually showing very clearly right now, so it may be
Oh, yeah.
the venue.
Your presentation is up.
Okay. So I'll
Is
continue.
it okay, Renee? Renee?
Brent, should I
Oh,
continue?
okay. So we're good to go.
Okay, fantastic. Okay, I'll just begin. I'll start here then. Let me just go here. In many countries, city targets are more ambitious than their national government commitments. The signing of the Paris Agreement in 2015 was a turning point for city action. Sorry, I can't, because I've changed the screen size, I can't move these slides now. Let me see what I can do here. Okay.
That's good.
Yeah, is that better?
Yeah, that's good enough.
Okay, why don't we just continue this way then? Okay. Accenture, a global professional services firm, has given a lot of thought to sustainable cities. They highlight in a new report that value exists at the intersection of digital technologies and sustainability. Their thesis is as follows. The companies leveraging it are called twin transformers and are 2.5 times more likely to be among tomorrow's strongest performing businesses than others. The companies that will master digital technology and the companies that will put sustainability at the heart of the strategy will probably be the winners in this new future world. So having the perfect understanding of the two trends of those two technologies is going to be critical. So let's learn more. To start the journey, twin transformers combine resources to scale technology applications to sustainable practices. Twin transformers invest more in innovation across the board, with 45% investing more than 10% of their annual revenue, rising to 57% in upcoming years. Twin transformers do not just spend more, they also embrace the idea that sustainability and technology are not two separate areas to prioritize. They direct innovation investment consciously to initiatives that bring together sustainability impact and the power of technology. Some do so by earmarking a specific share of R&D investment to sustainability and technology combined. Others set up dedicated innovation entities tasked with developing, testing, and scaling business ideas that deliver sustainable impact through technology. Companies are also discussing their approaches to technology and sustainability with shareholders, while investors are increasingly scrutinizing those companies' non-financial impacts. In 2020, 46% of European companies with the 22,000 largest companies worldwide discussed sustainability-related topics in earnings calls. That's up from 27% in 2018 and 20 percentage points ahead of North American peers. In the same year, 52% of those top European companies also discussed technology-related topics in earning calls on par with peers in North America and Asia Pacific. Accenture outlines a 5-stage approach on how to execute a twin transformation. Number 1, foster business models driven by sustainability and enable technology. Most twin transformers, 61%, already generate more than 10% of their revenues this way, and nearly 80% expect to do so in the next 3 years. Number 2, combine resources to scale technology applications to sustainable practices. Twin transformers invest more in innovation, with 45% investing more than 10% of their annual revenue. They also recognize that sustainability and technology are not separate priorities. Number 3, create ownership throughout the organization. Twin transformers assign KPIs that go beyond financial results. Examples include KPIs that relate to progress on emission reduction, the share of products with positive societal impact, and the share of resources procured from sustainable sources. Number 4, align partners for sustainable product life cycles and improved traceability. Twin transformers actively engage suppliers in their sustainability journey by embedding criteria into the screening process and offering training to raise the sustainability of the value chain. And finally, lead, empower, and nature talent. Twin transformers are acutely aware of the importance of the human factor of transformation and the challenge it presents. Here are some corporate examples of global companies embracing the trifecta of technology, smart city, and sustainability. Siemens is investing in simulation and digital twin technology to optimize the environmental performance of its products and services throughout the life cycle. Siemens has declared simulation and digital twin to be a company core technology, aiming not only to benefit from applying the technology, but also making a decisive contribution to reshaping it. Schneider Electric developed and convened the New Energy Opportunities Network, a global community and online market platform of over 300 corporate renewable energy purchasers and solution providers. Schneider Electric and a large retailer are using this network to support the retailer's aim to reduce CO2 emissions that would otherwise have been created through their value chain. To date, over 2,300 suppliers from 50 countries are participating in this project. They have already reported preventing a total of 230 million tons of CO2 emissions since 2017, and over 20% of the target through more efficient use of energy, agriculture, and forest resources, as well as lean recycling packaging, waste reduction, product use, and design. And finally, Accenture and SAP are expanding their decades-long partnership to help companies embed sustainability across the full spectrum of their business operations, from strategy to execution, to unlock the new value throughout the enterprises and their value to supply chains. Combining SAP technology and Accenture sustainability services and broad business data, the partners are increasing their reliance to together produce new solutions which will empower corporations to accelerate their progress on totally decarbonizing their supply chain and capture their share of the projected 4.5 trillion economic growth that is in the circular economy. I now would like to introduce Dr. Renee Marcos, who will highlight the important work at Alice Technology and what they're doing to enable the field of sustainability and smart city.
Thank you, Brent. Can you see my screen and hear me?
Yes, we can.
That's great. So thanks for inviting me.
We see your face only, no presentation material.
Really? Oh, try again. I'm sharing screen.
Yeah, I can see his slides.
Ooh, we don't see it in Korea.
I think that.
Oh yeah, I see the screen with the presentation material on, but I don't see your face. But this is better, I guess.
Okay.
Right?
Yeah.
Okay.
I think there's a mix-up between the panelists and the attendees, and so the attendees sometimes see the screen and vice versa. But you guys can see the screen.
Yes.
Okay, let's stick to that. I think that's the more important piece. And you can hear me.
Yeah, definitely.
Wonderful. Well, thanks so much for inviting me. My name is Renee Marcos. I'm the founder and the CEO of Alice Technologies, and I'm also an adjunct professor of construction management at Stanford University. I am a construction guy through and through. I've spent my whole life building. I have built $350 million pipelines or gas refineries in Abu Dhabi. I've done underwater pipelines in Beirut. I was also a civilian in Afghanistan, designing, building, and reconstructing the country. I ended up doing my PhD at Stanford University in artificial intelligence applications for constructions. There's a lot of talk about sustainable cities. We are also involved in several initiatives in that regard. And what a lot of people sometimes forget is that those cities need to be built, right? Sometimes up to 40% of the carbon emissions of buildings are in the construction phase, right? What we've done at Alice through our research is we've built the world's first generative construction simulator. It is a software that is capable of taking a construction project and figuring out how to build it with usually around 17% faster duration, 13% less cost or less resources. I'm going to show you guys how to do it. And so if you were to look at construction as a field, construction represents about 10% of world GDP, right? $10 trillion of labor, equipment, materials are delivered to construction sites every year, right? And the way that this is done today is it's done using this. This is the state of the art of construction management today. $10 trillion worth of resources around the globe are managed using one of these. This is a very manual process. It's extremely inefficient, right? You have to manually create it, link it. It doesn't optimize itself. It doesn't tell you the best way to build a project. It doesn't really do anything, anything other than a simple calculation, right? Perhaps most importantly, it was invented in 1961 and hasn't changed since. And so with Alice, right, that technology itself, right, results in substantial problems, right? A McKinsey study shows that typically large construction projects are 80% over budget and 20% longer than originally scheduled, right? We are the only major field in the world where this kind of statistic is our average. So what is Alice? Alice, it's an AI-powered algorithm that rapidly builds and rebuilds a construction project. On the right side, you can see an output of the system. What the software is doing is it's looking at lots of sequencing options. It will build your project with 1 crane, 2 cranes, overtime, no overtime, sequence ABC, CBA, fast drying concrete, regular drying concrete, 20 people, 30 people, and so on and so forth. It tries all of the different permutations of how to build your project, right? It is importantly a simulation. And what that means is that for the first time ever, the computer actually builds the project by moving resources around through space and time to build, the object. What that means is that the computer understands what are the implications of various changes in your input parameters, in your input variables. And finally, it's an optimization, right? And so what the software is doing is it's squeezing out performance. And the way it does that is that it finds more efficient ways to use the existing resources, or alternatively, how to use less resources to do what you need to do. Let me show you an example that we worked on in New York. It's a high-rise project. It's $170 million, and it's an interior fit-out, right? And what we did there was we basically ran the software in 2 scenarios. We ran it with the humans, manual process, and then we optimized it with the software. This is the output of the system. What you're looking at here is the number of people, number of crews that you're using on these dates. Right? So you can see here that we start with a few, and then you use more people and more, and so on and so forth. Each color is a different resource type. So green could be carpenters, blue could be steel workers, red could be, heating, cooling, and so on and so forth. In construction, what tends to happen is your resources come after each other. So for a high-rise building, maybe your heating and ventilation crews go in, then your finishing crews go in, then your painting crews go in, and so on and so forth. And then the heating ventilation crew goes to the next floor. And then the ventilation crew goes to the next floor, and the painting crew goes to the next floor, and then the 3rd floor, and the 4th floor, and so on and so forth. So what your crews are doing is they're cycling. They're cycling through the building as they're building. Notice that there's a jagged pattern to your construction here. This is because there's an inefficient cycle. There's too many carpenters, so they work very quickly, but then they don't have the next floor to go to, so they wait. The people behind them are catching up, right? So people kind of rush forward to the next floor and they stop. Then the people behind them rush forward and they stop, and they go in and out. When you run it through the software, what you'll end up with is this. Notice the nice smooth pattern, right? And what that's showing you is that your cycle, right, through the system is very efficient. They're not starting, stopping, starting, stopping. There's not a lot of people one day, less people the next day, a lot of people one day, less people the next day. And let me show you again. This is the inefficient, humanly calculated solution. You'll notice that there's a up and down pattern of your resources. And also notice the number here. The average crew utilization on this project is 58%. So on average, I'm using my resources 58% of the time for production purposes, not for cleaning, not for coordinating or rearranging. In the optimized solution, you see a very smooth pattern, and that number jumps to 68%. So once again, humanly calculated is 58% resource utilization. After the optimization, it jumps to 68%. That's a 10% improvement in efficiency or a 10% reduction in carbon emissions. You can imagine what this technology applied to the global construction industry could do in terms of sustainability and speed of construction. Overall, these are the average numbers that we see with our technology, about a 17% reduction in the project duration, 14% in labor cost, and 12% in equipment cost. Cost is equivalent to carbon emissions, right? You are reducing the amount of time that the machine has to work, right? And so that was my presentation today. Thank you so much for inviting me. I hope you enjoyed it. Back to you, Brett.
Yeah, thank you very much, Dr. Marcos, and also highlighting and addressing the practical building options that lower CO2 footprints. With that, I turn it back over to Professor Dan Choi.
Okay,
for the
thank
next.
you. Thank you. That was a great speech, Renee. Very nice. Okay.
Thank you. Thank you very much.
We are slightly behind the schedule, so I'd like to move on to our keynote speech by Dr. Maha Ashur. As was introduced by Dr. Moon, she's just excellent. I mean, beyond that, she's been selected as a top 50 female entrepreneur very recently, and I realized that she was ranked up in top 5 or something. So that was great, and she has a long list of her career path in my note, but I don't want to delay too much. So I'd like to welcome Dr. Maha Ashur for her keynote speech. Please.
Thank you so much, Professor Choi. Can you see my slide? I think seeing my slide is more important than seeing me. And can you hear me?
Yes, nice and clear.
Perfect, very good. Well, thank you very much. I will try to go over my slide in a much shorter time so we can catch up and be on schedule. In my presentation, I will focus on the key topic of today's event, which is smart cities, as well as the key milestones of autonomous vehicle, which play, as you will see, a major role. And in this opening slide, I captured all the various solutions that MetaWave is focused on, basically building the missing sensor for ground transportation, and very soon for aerial transportation, and as well as on the connectivity side, enabling a key solution to deploy and roll out millimeter wave 5G network efficiently and cost effectively. I will not go over the outlines as I will be going over my slides, but as I mentioned, the two key industries that we're focusing on is building the primary sensor. As you will understand, it is not a camera and it's not a LiDAR, which are the most common sensor. It is a radar, so it is a boring sensor since the technology is quite complex compared to optical sensors. And also on the 5G side, building repeaters and relays very economically to increase the coverage, lower the power consumption, which basically translate into green deployment on the global economy. All right, so MetaWave solutions consist of radar sensors. As you will see later, this is a very critical sensor that is key to enable safety as well as full autonomy. And both on the ground and in the air. We are not a tier 1, as you will see, so we do not build a full sensor. We build platforms for our customers that will produce the radar. We are a tier 2 plus, where we build these missing components that enables high performance radars. And on the 5G connectivity, we build repeaters and relays to extend the coverage of radios. Let's see where we are today. I borrowed this slide from Gartner 2020. This is after COVID. And you can clearly see where these technologies are on the hype cycle. So flying autonomous vehicles still far away from now, but it's going over the peak. And we see that translated in all the SPACs that have been filed with billions of dollars raised for urban air mobility. And I will go over that in the next few slides. You also see something interesting on the micromobility, especially due to COVID. We've noticed an increased jump in the adoption of micromobility in urban area. And also something that you want to keep in mind, autonomous vehicle is not something that's going to happen in the next couple of years like everybody have been talking about, but it is a more technology that will be maturing over the next 10 years. And something also to notice in the past few years, especially since COVID, that the car OEMs decoupled autonomous vehicle from electrification, focusing on the EV car first and then on the AV car second. And due to COVID-19, we have seen an increased interest in long-haul delivery of goods. Some of them is even through drones, and then delivery robots. You saw some of the pizza truck delivering food and so forth. So there are a lot of dynamics that are happening due to both global warming as well as COVID-19. So what does this lead us to? If we fast forward 10 years from now, you will see that the connectivity, the secure, reliable, low latency connections enable these ecosystems to happen. And mainly the true convergence between mobility, which is transport of goods and people, and also the edge services enabling real-time telehealth, real-time training, shopping, and so forth, all converging into the ability to provide mobility as a service, as well as all the added application that goes on top of that. So hopefully we will all witness this evolution, in major cities in the world, and hopefully soon after that in developing countries. And why this is happening? Convenience. As we know, the next generation of drivers basically refuse to own a car because they see that as a burden. Maybe us, we saw it as a freedom to be able to move from one point to another. This next generation of drivers, they prefer to drive with Uber or Lyft so they can be connected all the time to their apps. And also productivity, being able to even work when being transported from point A to point B is very critical, especially like executives when they go to the airport, they take Uber or Lyft so they can still reply to emails or make phone calls. So it's very critical that this mobility as a service in urban environment, both on the air, on the ground, will enable these kind of features. In order to accomplish that level of adoption, trust and safety are going to be a key. What do I mean by trust is that the industry should not overhype technology and should also educate the consumer about the technology that they are currently experiencing during these movement. And of course, the safety. And as I mentioned in my previous slide, that will be actually the ultimate convergence when true mobility as a service happen with all the added services during the ride. So let's focus on urban air mobility. Like I showed you in the hype cycle, we're getting into the peak for a very good reason, because lots of SPACs have gone public and raised lots of amount of money in terms of building these electrical vehicle that operates in major urban cities. We're talking about in the United States, 25 to 35 urban areas, very dense urban areas like New York, San Francisco, Los Angeles, and so forth. And a typical ride is around 50 miles radius. These are all electric. And as you will see in some of the case study that I will go over, it actually does solve a major problem facing ground autonomous vehicle and robotaxis. So these are kind of various hardware that has been developed, and even I think the US government has announced Agility Prime for flying cars. So a lot of activities in that space for a very good reason, that in the air you don't have bicycles, you don't have pedestrians, you don't have potholes, you don't have rocks. It's much easier, much cleaner space. Perception is much, easy to process and also to deliver on the safety. But of course, because these are vertical takeoff and landing vehicle, being able to operate in all terrains will become much critical. And this is where the radar basically plays a very major role. So let's see a case study in New York. If you're trying to go from Manhattan to JFK during peak hour time, the drive takes around an hour and 15 minutes. And if you take Uber, it costs probably between $60 to $90, depending on the availability of this vehicle. And if you decide to take a helicopter from downtown New York to JFK, it costs you around $1,000, cuts the time to 20 minutes. Question is that, can you combine both of these nice worlds, where you will still pay $60 to $100, but instead of spending an hour and 15 minutes on the roads, you are in the air. And with that, you are also reducing the traffic on the ground. So that's basically what these urban air mobility are promoting. I think United Airlines already signed an agreement to procure some of these eVTOL vehicles in order to extend the delivery and also the transportation of their key customer to the airport using what we call United UAM flights. Now, so that's kind of the ultimate goal down the road, and it's going to take time to get there. So let's see where we are today. As you know, pre-COVID time, Lyft and Uber have been extremely popular and also adopted in major urban areas where municipalities and federal government are not against it. So 70% typically of these ride-hailer are met compared to 50% taxi utilization. And I think that gap keeps increasing over time, even post-COVID. And during this ride, the driver itself takes 40% of the total cost. So in New York, for example, it costs $22 for the driver, and that excludes the fuel, so 40% of that goes to the driver. It makes it extremely difficult for Lyft and also Uber, for example, to get to their profitability with these kind of numbers. So the question is that, how can you eliminate the driver while meeting higher level of safety and security in order to make these mobility as a service, like what Waymo is doing, Cruise is doing, and even this morning, Mobileye is doing in Germany, more predominant. So let's go over driver assist versus full autonomy. I painted to you a picture about autonomous vehicle, full self-driving cars, but there is a hype. And as I mentioned, truth is extremely important as you educate the driver, because the regular driver is not a high-tech person and not tech savvy. So they tend to trust, especially Elon Musk. Many people look up to him. And he has been misleading his audience, especially with his full self-driving feature that he charges at $10,000 for this added feature. And the question is that this technology still doesn't exist, even though he calls it FSD. So with more and more EV competition coming from the top companies like BMW, Audi, GM, and so forth, they will eliminate such hype, because these conventional car OEMs, they are very conservative with their messaging to their consumer. So truth is very critical. Safety is even more critical. So recently, as we know, that Tesla removed the radar from their Model 3 and Model Y. And the reason is basically to reduce the cost, since they don't build these radars, they build the cameras. And also because their sensor fusion is more geared toward processing processing the images that are coming from cameras. And the radar is a completely different beast. So this is where MetaWave actually comes along to address that deficiency. And you can see by removing the radar, the car is becoming more and more confused. So you can see in this example where it says that most of the incidents that happens, the crashes, they happen with this autopilot. I would call it autopilot because it's not full autonomy, happens in the dark. And especially when you have a vehicle with lights and flares like fire trucks, like police cars, And because the sensor fusion becomes overwhelmed with these flickering of lights, that it becomes extremely difficult for it to analyze the additional objects, especially during the dark. So EV competition will guarantee higher safety, that's for sure. This is another example where the driver said it happened very fast. All what she did, she just bent down to pick up her cell phone that dropped, and she basically hit that car in front of her. So if you had a radar that basically is part of your sensor fusion in a more primary fashion, this vehicle that is parked in the dark will be very visible, because radar operates completely differently from a camera, and it does not just receive a photon at the sun or whatever lights are reflecting on, but it basically sends a signal and detects signals reflecting on this metal vehicle. And that's why all the cars that we drive today, they all have radars. So the ability to add this high performance long range imaging radar with the sensor fusion at the edge and in the centralized software stack is going to be essential. And this is where we see EV competition will always use smart radars. And at the end, this is a quote from Elon Musk, where he said, "Yep, this thing we're building is really hard, and honestly, we're not there yet." so it's, and everybody
Finally.
realized earlier that this is the case. How am I doing with time?
We're good. I mean,
We're good.
slightly behind, but we're good.
Okay, perfect. I'll go faster. So welcome to MetaWave, where MetaWave is building the spectral radar and also the perception, the aware edge perception that comes with it. Our solution, as I mentioned, is targeting urban air mobility, is also targeting last mile delivery, cars, both autonomous vehicle as well as driver assist, AV trucks, trains, and it has been actually tested on trucks and trains and car. And of course, with the high performance radar, we always target the smaller size, lower cost in order to meet the OEM expectation. We'll skip the slide since it's a little bit more high technical, and I will just share with you a couple of videos that basically shows how the radar operates in one example in a foggy condition. So you can see this is a very high-end camera. This is not the camera on the Tesla, but you can see how it is struggling to even detect object far away. And then you have a very high-end Velodyne LiDAR, and you can see also the Velodyne LiDAR, which is that red cloud around the radar, cannot even pass 10 or 20 meters. So another reason for why radar is extremely critical is to be able to operate in bad weather conditions. And that's why urban air mobility and also aerial vehicle look at these radars. Another one is the perception. So in order to fill the brain of the radar, since radar doesn't see very well like camera and LiDAR, operates at lower frequency, we basically train it with LiDAR and camera. So we have a full sensor fusion system where we collect all the data, we train the radar. Once the radar is trained with the AWARE platform, we don't need any feedback from the sensor. And we are today at 94% accuracy. I'll play the video where you can see, so the red here is the Blackmore LiDAR, but just used as a reference. But you will see the pedestrian are being labeled in yellow, the cars in green, and static objects are in blue. Run the video and you can clearly see that the AI engine operates all the way beyond 300 meters. So with that kind of information fed to the car, let's say the Tesla car that is driving at night, will be able to see the parked car even far away, and will be able to make a judgment to stop, slow down, or change trajectory. So achieving the perfect driver assist or autonomous vehicle requires all-weather operation, requires fast response to be able to let the car react, and also you need to have a near perfect perception. When I say near perfect perception, because human brain are not perfect. So we cannot operate in bad weather conditions, but we expect that the mobility as a service to operate in bad weather conditions as well. And also be able to meet the reasonable cost to the consumer. And of course, most importantly, the lower power consumption, since most of these vehicles are EV vehicles. And I put here some of the challenges that the sensor fusion need to address. the hazards on the road, the cut-ins, cut-outs on freeway, detection and tracking, drivable surface recording, and the identification of potholes and so forth. I'm going to skip this slide. So with this, as I mentioned, MetaWave, as we build these high-performance radar, we are protecting our innovation. So we filed over 260 patent applications, with 25 of them being issued and allowed, both in the radar space. You can see here in the top right circle how many of these patents are filed for radar and how many are filed for 5G. It's very critical for companies or startups disrupting the status quo to protect its innovation so it can create barrier of entries to others as they try to compete. I can also skip the slide since you have all the text written with it. But I'll talk a little bit about consolidation because that's very critical, just to understand the value chain. So traditionally, of course, you have the semiconductor and IP supplier like GlobalFoundries. We heard the news about Intel trying to buy GlobalFoundries and so forth. Then you have the semiconductor suppliers. And here I added actually Qualcomm to the list. It wasn't there, but you have Intel, Infineon, NXP, and so forth. And then these basically suppliers, they provide their component to the tier one, Continental, Denso, Veoneer. Basically, they build the radar or they build the sensor and they deliver it to the car OEM. But that's kind of the traditional value chain. Of course, Tesla and others are trying to become completely vertical. So they basically build all their sensor, of course, except the radar. I won't be surprised if at one point they build a radar as well. But there is a consolidation that is happening because all of these tier one that you see in the middle are not going to survive 10 years from now, especially when you have the top three tier ones already dominating the market share ownership. So recently you saw that Magna announced that they want to buy Veoneer at $3.5 billion, and then Qualcomm came and offered an all cash at a much higher value. So mobility is becoming very, very clear that it will be an important sector, even for companies focusing just on the telecom, for very good reason, like I mentioned to you before. So it's very nice to see MetaWave is basically sits between the tier one and the tier two to enable this high performance radar. So we're very excited to be in that space. And the next few years are going to be very exciting because safety requires a balance of sensors, especially the adoption of high performance radar, like our Spectra radar. And also we will see an accelerated consolidation. It's very nice to be working with most of these entities and see how the collaboration and partnership are emerging. And hopefully very soon, and in my next keynote presentation, I'll talk about the paradigm shift, about how this connectivity and mobility are converging. Thank you very much.
Wonderful. Thanks for the wonderful presentation. I'm sure that we will have a little more time to discuss about your technology during the panel discussion to follow. Let's move on to the next keynote speaker, CEO of Edison Motors, Mr. Young-Kwon Kang. He has a very interesting background. He started his professional career as a TV production director, program director. And then he has a great vision in this, with this eco-friendly economies, and he became the CEO of Edison Motors, which produces the electric bus. And his company is actually leading the market, at least in Korea, and he's trying to expand his business globally. So his topic today is the autonomous EV bus by Edison Motors. So without further delay, please welcome Mr. Young-Kwon Kang.
Good morning and good afternoon. I am Chairman Kang Young-Kwon from Edison Motors. Up until October, we are trying to create a level 4 autonomous electric bus that can travel at 60 to 100 kilometers per hour. And we are planning to take this bus to Pangyo area where we have smart roads, which is 8.4 kilometers long. So we are manufacturing level 3 or level 4 autonomous electric bus that can travel on these smart roads. And we plan to put these electric buses that we manufacture on the road in Pangyo starting from November. As was put, the autonomous vehicles come with diverse limitations. In the bus, we are equipped with camera, LiDAR, and radar, and many other high-end sensors. And with that, one single bus can cost about $150,000. And to cost 2 units, it costs $350,000 with a lot of state-of-the-art sensors and equipment and devices. To put these on the road, we can make level 4 autonomous driving possible because the V2X is possible in the smart roads in Pangyo. All the data is collected by the telecommunication service provider in Korea and gets computed at the computer center, so that the real-time communication between V2X is possible. So autonomous driving is a thing. But then, can we commercialize it and can we just put it into market? No, we cannot, because traffic accident is a real threat. Autonomous vehicle is something that we can do with our autonomous driving car, but normal cars will not do that. So we're gonna have to wait for about 5 or 10 years for the autonomous driving to be more popular and be commonly adopted in the society, and that is what many experts say so as well. Then why our company insists on investing a lot of money in making autonomous vehicles and R&Ds? Why? Because there is demand. The bus that we manufacture will have to wait 5 or 10 years to drive on the road. But when it comes to e-vessels, we can adopt our technologies to e-vessels quickly. Let me take off my masks off. The technology we are developing can be used for electric yachts or electric boats. And in that case, in 3 to 5 years, we believe that autonomous sailing electric yacht and electric boat can be a thing. On top of that, we are currently manufacturing 18 feet, 33 feet, and 48 feet electric yachts. We have bought it and we are applying the electric motor from truck and equip it with on top of yacht to translate normal yachts into electric yachts. This is the research and the work that we are doing right now, transforming normal yachts into electric yachts. As for the 48 electric yachts, 435 horsepower engines are equipped with. Actually, 2 of them are mounting on the 48 electric hybrid yacht. And by coincidence, the electric bus uses similar engine as well. So if things allow us, we can utilize hybrid setting for electric buses and hybrid yachts as well. Or we can apply 320 horsepower engine to translate the yachts into electric ones. With the 2 Caterpillar engine with 435 horsepower on diesel, For the back and forth trip between Busan Port and Jeju Port, on the diesel, it takes about 80,000 won for fuel. 80,000 won only for fuel. But with 1,000,000 for fuel, but if we use electric energy to travel back and forth between Busan and Jeju Port, it will take less than 1 million. And we're also working in the field of UAM as well. And I'm showing you some pictures of the UAM devices that we're working on that can maybe carry containers. Even considering autonomous flying feature, we believe that in 3 to 5 years, we can manufacture them and put it to market. And at the same time, we are trying to apply this autonomous technology to SUVs and the sedan cars as well. We are preparing for the era of autonomous driving that will definitely come. Also, with population aging, some people might not be able to drive going forward as they age. That is why I believe the autonomous driving will have a huge demand from the public. I saw news that in Tesla is trying to put 4 people passenger car that worth $25,000 with autonomous driving technology and sell it to the market. Although he sometimes exaggerates, I believe the camera-based autonomous vehicle should be made in the market in order to spread the use of autonomous vehicle and the technology to the common public. As of today, we are mostly focusing on EV cars and electric bus. Electric bus and electric truck. New e-hybrid 110 is used for low-floor EV, low-floor bus in Korea. I am confidently saying that this EV bus boasts the best performance available in the world. I'm saying so because this bus is using carbon fiber and thus way lighter than many other EV buses available in the market. We have an autoclave there where we can use and accumulate carbon fiber to create the bodies of the EV buses that we manufacture. So when compared to other competitors, we are 1 to 1.5 tons lighter. That means we can reduce the fuel efficiency, improve fuel efficiency by 15%. And as you are well aware, carbon fiber is one of the best materials. It's non-inflammable, it's light, and it is resistant to corrosion. After using this bus for 10 years, we buy this bus back so that we can transform into camping cars for couples or the small container house for the users so that they can be used for office purposes or housing purposes and also traveling purposes as well. That is the project that we have in mind, buying back the bus that we sold and transforming them into camping cars and deliver them to users. And as was mentioned by the MC, before I started working in this automotive field, I have been producing TV programs. And back then, I made a very famous investigation journal program that is still airing in Korea. I have been retired from the broadcasting company 23 years ago, but the program that I produce still gets aired. And what I found is that when I was focusing on investigation journalism to produce the show, I wanted to listen to what people wanted to say. However, I just wanted to look at the show not from the producer perspective, but from the watcher's perspective. And I thought if I can create what watchers want to see, this would sell and succeed. And indeed, this program was a big hit. The viewers' rating was 43.8%, which is a whopping number. In one of the especially successful episodes titled A Missing Wife, it recorded once again 43.8% of the viewings rating, which is almost double the average rate of 27%. I'm saying this because in manufacturing car, I try to approach car making from the producer's perspective. I'm not trying to approach car making from the manufacturer's perspective. I just don't want to assume what customers want to buy. So I try to think from consumer's perspective when trying to manufacture a car. If I were a consumer, what kind of car do I want? Maybe I want a safe car. I want a sturdy car. Or I maybe need a car with an eyeglasses holder as a glasses user, or I might need a car with a wireless charger mounted on it, or I might need a car with autonomous driving feature. So I thought car manufacturing from the consumer's perspective, and that is why I acquired car manufacturer. And now that I manufactured my car, I just wanted to compete with Tesla. That is why I named my company Edison. Edison is much more famous than Tesla if you think about it. And when I was a PD and as a CEO and businessman as well, in my entire career life, I have always been focusing on what we can do to reduce the carbon emission and improve environment. There is a professor from Stanford University called Tony Silva, and he said that by 2030, all cars will be made into electric cars. And I agree. Recently, some say that we do not necessarily have to wait until 2030 and the EV car will happen and be fully commercialized and popular by 2025. If the EV battery price reaches $100 per kilowatt hour, the price or cost for building EV car would be equal to producing an internal combustion engine car. Then why buy or why make internal combustion engine car? So there is economic reason why I believe EV car will be a thing. But there is another reason. With the CO2 emission at the current rate, because of the global warming, our next generation might suffer a lot. We cannot guarantee a good life for our future generation. The Global Carbon Project measures CO2 emissions every year, and as of 2019, the number was 34 billion tons, and among them, Korea emitted 600 million tons, China 10.1 billion, and the United States 5.2 billion tons. And if the trend continues, by 2100, the global average temperature will grow by 2 degrees Celsius, which can put immense suffering to human life. And to prevent this from happening, we have to decrease our carbon emission by 75% according to some arguments. But recently, some experts say that even 4 degrees Celsius or 6 degrees Celsius or 8 degrees Celsius to increase in temperature is even feasible if the current trend continues. There is a documentary titled Before the Flood featuring DiCaprio made by National Geographic. And if you look at the documentary, the glacier melting speed is accelerating. It is actually 4 times higher than before the industrial times. And because all these human-induced activities we're suffering from, SARS and MERS, and now we have COVID-19 pandemic where we are forced to wear a mask. In order to prevent another such event from happening, we have to create Earth a livable space and inherit better place for our future generation. And for this, transition to eco-friendly cars is a must. It is not an option. In this regard, starting from 2023, China has been focusing on EV car rise at the national level. It is trying to eradicate or remove all the diesel cars. And this project, by the end of this year, would be made successful. By the end of this year, it is expected that EV cars will take 69% and natural gas cars 17% and hybrid car the remaining percent, replacing all the diesel cars. I mean diesel bus. And replacing all these diesel buses into EV buses, only that would help China to reduce the CO2 emission by 33 million tons. This is the Chinese government-led policy, and I believe China is doing a great job in this regard. And not only in the field of EV bus, but also in the EV car area, the Chinese government is providing a lot of subsidies to all EV cars. As of 2016, the Chinese government provided 45% of all the EV car units available in China, thereby providing impetus behind this cleaner transition. In terms of manufacturing EV cars, I'm trying to be practical. In creating one autonomous vehicle unit, it costs $1.5 million per unit. And if the cost is so big, nobody would buy it when it is 10 times more expensive than normal cars and 5 times more expensive than just normal EV cars. Such a high expenses would increase the cost from the end user perspective as well. And with that, we are trying to be more economical and practical in our approach to manufacturing EV cars. In producing and manufacturing EV cars, the core is motor, battery, and electronic control. And in these 3 parts, we can design on our own and develop both software and hardware on our own in these 3 core technologies. We have developed MSO coil and developing a motor along with the Korea Institute of Industrial Technology. This MSO coil motor comes in 2 forms, one cylindrical and the other disc type. And as for the disc type coil motor, the efficiency of it is 97.6%, while the cylindrical motor's efficiency is 95.4%. We have developed this motor in 2019. And if you look at the picture on the top of the left, that is the motor that we have developed. And according to tests, our maximum efficiency was 98.22%. I was so happy to this number and wanted to mass produce this motor as soon as possible, but the researchers and the doctors from the Kitech said that I have to wait at least 3 or 5 years to adopt this motor to EV cars. Then what should we do while we wait? We decided to apply this motor in electric buses as well. If you look at the top right, this is the motor that we use for electric buses. The skater and rotor can be reverse engineered to use and be retrofitted with MSO coil. And many doctors said that it will take even more time in developing MSO coil motors for EV cars, but I insisted. And after some work, in December 15th, 2020, the design was over. And this year, we finished all the tests, including dynamo test, and we're trying to mass produce this EV motor using MSO coil starting from next year. This motor boasts a huge and great performance. It can match the motor used for Benz. It weighs 96 kilometers, the motor that we developed, but as for the Benz, it is 270 kilograms. It weighs 270 kilograms, so that is why we boast superior performance. And another core part of our EV bus is smart BMS, and I dare to say that we have a technology that denies comparison at the global level. I can say this because if you look at the existing EV cars, not only in the battery pack, the BMS management capacity usually creates problems when it comes to traffic accidents, reduced cycle, and the fire hazard, and so on and so forth. And we didn't have solutions so far, but researchers at our company digged this problem deeper. Actually, many workers from LG company moved to our company who have been exploring this issue for a quite long time. Some of them even spent 3 years learning this technology in the United States. I invested and I gave them the share of the company to make sure that the researchers from the LG does not leave and just create their own company but join us. When it comes to the normal BMS, so-called second generation BMS, they can measure voltage and current and the temperature and so on and so forth. But despite everything, they still have the risk of creating fire and reduced life cycle. And our smart BMS, the third generation BMS, has a much better performance. I am not saying that we eradicated all the problems and we are 100% safe, but I can confidently say that our third generation BMS does a much better job when compared to the second generation BMS. So I dare say that we have a very good technology and we do not want to hog this technology. If we see demand, we are open to share this technology with others. We are developing our software and hardware, and we can sell these software and hardwares along with the technological solutions and alternatives that we developed so that we can prevent possible risks from happening as much as possible. And among our technologies, I mentioned smart BMS, And we also have total management system. And if we link to these technologies, we can find out our buses, even if they are in deserts or even in cold Siberia of Russia or even humid coastal area or high mountainous areas and so on and so forth. Depending on where the electric buses are in terms of their surrounding environment, we can collect their data and analyze it at the cloud server that we possess. And depending on the data, we can analyze what is the most effective way for the EV bus in that specific condition and surrounding environment is possible. And we provide such optimization information over the air so that we can remotely improve the bus's performance. And we can do pre-diagnosis for future failures and remote maintenance. This is such a great system, I dare say. We have been providing EV buses for more than 10 years, and with that, we understand the importance of charging system because this determines the efficiency of the EV bus. Sometimes the charging system works for this bus, not for that bus, and vice versa. I think this is a problem not only in Korea but also in many other countries around the world to make sure that we have a consistent charging condition and effective and efficient charging system that saves energy as well. We are creating a centralized charging system so that we can control the efficiency and consistency of the electricity charging at the central level. With that, going forward, we are trying to provide a one-stop total service from the purchase of the EV cars. And if consumers want, we're trying to provide financial programs as well. And we will provide charging related services as well. And once again, the name of our company is Edison Motors. And Edison was such a great inventor to make sure that we do not taint his reputation. We will make sure that we provide one-stop service that encompasses parts, equipment, EV car, and we are trying to create an EV mall for you. That would be the website where global consumers can take a look and feel confident that the devices, parts, and the cars from Edison Motors is safe to use and guarantees performance. We believe, to put it bluntly, consumers are the king. We want to provide an affordable and fully functional cars and services and parts with high performance. That is the mission of our company, and with that, I would like to conclude my presentation.
And now we have a panel discussion in line. And for that panel discussion, I would like to invite President Eugene Yoon. He is a CEO and a managing partner of EOS Investment Partners. And he started his career as a university professor at British Columbia in Vancouver. And then he went through multiple financial sectors to serve internationally. And he's truly a global entrepreneur. And then I'd like to ask him to lead this panel discussion session. Please welcome President.
Thank you. Thank you so much, Professor. It is a great pleasure for me to lead this discussion. We have a small problem because we're very much over time. We're due to have a break, according to my schedule, at the top of the hour, which leaves us about 20 minutes rather than the scheduled 45 minutes. So what we will do is maybe a compromise solution, spend 10 minutes of the break go 10 minutes into the break, and we'll try to finish at around, in Korean time, 10 past 10, so about 10 past 6 o'clock over on the West Coast. Okay, so it is a wonderful pleasure for me to also invite 4 very distinguished experts to do with autonomous vehicles to join me in this panel discussion. You've already heard from Dr. Maha Ashur and also from Chairman YK Kang. And together, we also have invited Dr. Ali Izadi of Bloomberg. He heads up the research and is fortunately based in Korea, so we have very good access to Dr. Ali. And also Professor Dan Choi, who's been Master of Ceremonies so far, is going to join us as one of the panel discussion members. So I've taken up enough time. I want to quickly go into, I think what I find is the most, is the biggest question in my mind, and I want to pose it to our discussion panelists, and that is, in my mind, I have no doubt that we will go to autonomous or driverless cars soon, at some point in the future. And the soon has been mentioned as being immediately around the corner. Elon Musk seems to think we already have it. On the other hand, the time frame keeps getting pushed further and further away as the calendar years move on. So I want to ask our distinguished panelists, where are we in the time frame, and will we really reach full driverless cars, meaning no one sitting in the driver's seat? Okay, will that ever happen? So I want to begin by asking Professor Dan Choi.
Am I in line?
Yeah,
First?
because I feel that in an earlier discussion with me, you said you had some negative views about that question.
Not fully negative, but we have to face the truth. As a human, we've been driving a car over 200 years now, right? Either it's internal combustion engine or electric vehicle, I don't care. We've been driving the car over 200 years. We're still causing problems, accidents, sometimes minor, sometimes fatal. With this advanced technologies like perception device, fully integrated perception device like the one from MetaWave, we know the sensors are going to work, and we have a great actuation systems. But the decision process, whether it is a legitimate obstacle, or it's pedestrian, or it's another vehicles, it's really hard to tell. And we also have a problem of unexpected event, unexperienced event that can happen on the road. So in order to cover all those situations in nice and safe, we just have to be not negative, but we have to approach carefully. And a lot of people are expecting to see this autonomous vehicles are going to be on the road in its full capacity within 5 to 10 years, but I would say we need about, well, I don't know, more than 10 years. So not just by the technology standpoint, but the experiences that we have to accumulate to integrate with all those nicely developed hardware devices. That's my point. So we have to look at the technology in a long-term time frame so that we can get there ultimately. That's my opinion.
So Dan, do you feel that we will ever reach real driverless situations? No one in the driver's seat?
I do believe so. I mean, as the more we have autonomous vehicles on the road, we will get to that point very quickly. I mean, autonomous vehicle and the human driving vehicle, if they are mixed together for about next 50 years, we won't be able to reach to that completely driverless vehicles on the road. But if we fill the road with autonomous vehicles only, then we'll get there very quickly. So it's going to be a very sharply increasing that we will reach to that point. That's my opinion. Yeah.
Okay, thank you very much. Ali, I'd like to pose the same question to you. You've done a lot of research and you've been to many conferences with distinguished experts. What are your views in the time frame regarding the AV?
Thank you very much, Professor Yuen. Good morning and good afternoon, ladies and gentlemen. My answer would be very similar to Professor Choi. I think the challenge is really when you're in that mixed environment, and Dr. Ashur already in her presentation alluded to some of the challenges there. If actually, Professor Yuen, so you had lived in Vancouver before, you may remember that around Vancouver there's a thing called SkyTrain, and SkyTrain is essentially an elevated rail line and it's driverless, and that has been around for decades. And this kind of technology has been all around the world, including here in Korea. So when you have a very controlled environment, realizing autonomy is quite easy. The challenge is if you want to have personal vehicles in environments where there's a lot of unpredicted events that can happen, that challenge gets exponentially harder. Having said that, there are some cases, there's some really interesting low-speed shuttle developers, for example, Navia, EasyMile, others, that those applications might be realized a bit quicker. As Professor Choi also mentioned, like, yeah, if you want to ban human-driven cars in specific stretches of the road today, then you can also realize that sort of driverless personal car more quickly. But the economics and legal challenges of that are quite hard. So from a level 4 personal vehicle perspective, based on the testing data that we've seen from California and Beijing, as well as considering the economic and legal challenges, I think we're probably talking another couple of decades. That doesn't mean we're not going to have ADAS, as Dr. Ashur already discussed. So obviously you can already go and buy vehicles that have ADAS feature, but ADAS is not level 4. And that transition from ADAS to level 4 for personal vehicles, I think it's going to take a lot longer than some may have hoped.
Okay, that's not music to my ears. I was thinking of stopping driving when I reach 70, which is pretty soon. And if I have to continue to drive at that age, I feel I will be responsible for many accidents on the road. So that's really not good news. Maha, I'd like to turn over to you with a similar question, but if I could also advance the discussion a little bit. So you're doing wonderful work. There are interesting things that are happening in the field, generally to do with AV. What inning, you mentioned what inning we are in if we think of this as a 9-inning baseball game. What inning are we in? And what is keeping us from finishing the game, going to the 9th inning, so to speak? What are the main stumbling blocks?
Well, thank you so much for all my panelists' feedback. And I am not a baseball person, so probably the innings is not a good analogy. But I tell you, probably we are in the 4th inning, and it's a very slow initial game, with the first 4 innings are being very long. And I think the next 5 are going to be even longer. And the reason is you can have a level 4 car today on the street, but that car is going to drive very slow. It's going to take its time. It's going to map all of the road. The question, will the consumer be happy? Especially you mentioned us driving all that long, driving fast, trying to bypass things. We're going to be very impatient, in my opinion. So the consumer reaction to those very slow cars is going to be very negative. So how do we overcome that? That's going to be an issue. And I think there is a way, of course, to accelerate that development if municipalities, if governments issue a more, like we have bike lanes, maybe on the freeway, you're going to have autonomous lanes where if all the cars are going to be autonomous. This way you can guarantee operation, flawlessly. I just have to mention one thing about Korea. As you know, many, many years ago, cell phone industry emerged, and Korea was the first government to adopt a high-end CDMA phone technology, and that enabled cellular industry to thrive. So I hope Korea will also be a leader in that space to demonstrate feasibility of L4 cars in these smart cities, because it's not just the sensor, it's not just the software stack, it's the infrastructure that basically hosts these vehicles.
That's very interesting, Maha, because when we introduced new telecom technologies, I was very happy to be a guinea pig, okay? And I use that term here because if it's to do, because, and handphones could be, I was worried that they would send radio waves into my brain and I would, not function as well. And so there was a small danger of that. But with regard to, say, autonomous driving, there is a huge question of safety and life. It's a life and death situation. I don't want to be the guinea pig for that, and I don't want the Korean government to lead that effort for the world. That's not something I would vote for. How do you feel about that?
Yeah, but we cannot start with a negative view. We have, if the science tells you it can be done, you're not violating the laws of physics, that means it will be done. China, definitely, it will make it happen. And there are multiple ways to have, like, if you take a look at autonomous trucks for long-haul delivery, these trucks, they operate with full autonomy and on highway. So I believe, in my opinion, maybe 10, 15 years from now, it will happen. It's going to be a very slow rollout, and it will accelerate. Also, the adoption will accelerate once, in my opinion, the software stack, the fusion system in the car, and once you have a very robust V2X, V2B, V2I infrastructure that will provide this redundancy in the system, and it will help the cars collectively to operate in a safe environment. So I'm very hopeful, very optimistic, and I think it's going to happen in our lifetime.
Oh, thank you very much. Yeah. So you mentioned science. One thing I'm very afraid of is that sometimes the scientists aren't as good as they think they are. Okay, sorry about all the scientists in the room. And we just need to turn to the problems we are having with CDC, with the coronavirus, etc. You can see that there are a host of people who will not take the vaccine. By the way, I've taken the vaccine, and I'm doing pretty well, I think. On the other hand, people don't believe some of the results that are coming out, and it has to do with emotion, okay? It has to do with our feelings, and sometimes, the data as presented is not enough to convince us to get over that fear factor about our well-being. So, to think that data that says, driverless car or autonomous driving, machines are driving better than people, that is not enough. I've driven for 30 or 40 years. I've had no major accidents, just a few scratches in the car. And so it's not a question of comparing me to the objective statistics, it's comparing me to my inflated confidence in driving versus what the data tells us. Yeah? And I think the situation with vaccines also is people think, oh, I know my body better than what the scientists are saying, or I don't believe the data. So it's, I think it's a very tricky question. I know we will get to autonomous driving at some time, and thank you for saying it's going to take a very long time. The rollout is going to be slow, but I feel that the resistance is very strong.
I am one of those, skeptical. I've been driving my Tesla for 3 years, and probably I used autopilot only 3 or 4 times for exactly the same reason you mentioned, Dan.
Okay.
But I'll tell you, once I was on a freeway and I wasn't on autopilot and I was distracted. I was looking down on my cell phone while exiting to go to MetaWave, and the car in front of me stopped. Stopped because there was a bicycle crossing, and it stopped abruptly, and I was at a very high speed. Suddenly the car broke. It pushed its brake. I didn't brake. It wasn't autopilot, but it stopped. That's a life-saving.
Okay.
I was also once driving on a highway with my Tesla, and it was a narrow road, and the side of the road curved down. The car readjusted itself. It felt that the curve was going down on one side, and it knew that probably it's going to go down. It readjusted itself and put it on the road. So these kind of sensors are going to be very critical, and slowly the driver is going to gain confidence. The only thing that you cannot do, like I mentioned, truth. You have to be truthful when you provide these kind of services.
Right.
So I think, in my opinion, it is going to happen. And I will tell you, Dan, when you have more and more EV cars, now you have, I think in the next 2 or 3 years, more EV cars on the road with more sensors on the road, with higher level of autonomy, what I call a driver assist. That's how autonomy is going to happen. It's not going to happen over time, overnight, like everybody else thought a few years ago.
Thank you very much for that. I would like to turn to Chairman Kang for our next question. Before asking Chairman Kang, I would like to inform and everyone on the floor listening to our discussion here, you're welcome to put some questions into the Zoom system, and if possible, we will come to your questions and try to address them. So please go to your messaging and type in your questions, and we will try to answer those. Okay, Chairman Kang? Hello? Chairman Kang? 강 회장님?
Chairman Kang?
강 회장님, 안녕하세요. Hello?
안 들리나?
Okay, he seems to be a little bit, maybe there is an urgent matter that's distracting
He's in
him.
autopilot mode now.
Okay.
A little bit of distraction with his cell phone, I guess.
지금 네,
I think they have
강
a video-
회장님 지금
audio
질문 받으.
problem.
Chairman Kang, can you hear me?
네, Chairman Kang, I would like to ask you a question. So you mentioned that with your autonomous vehicle that's being currently developed for the bus system. 지금 들리시나요?
Can you hear?
지금 들리시나요?
Can you hear?
Chairman Kang?
이제 들립니다.
들리세요? Okay.
Now I can hear.
Start again. 영어로 해도 괜찮습니까?
Is it okay?
So you mentioned that with your developmental bus with AV, that maybe we are about 5-10 years away from doing level 4. Why is it taking so long in your mind? And a further question I would like to ask you is, Maha mentioned that Korea has great capabilities in rolling out new technologies, and you're right in the middle of that action, it seems. How do you feel about our chances with regard to AV versus the rest of the world in adopting this technology first?
Autonomous vehicle technology depends on how different people view in different perspectives. Often people think autonomous vehicle meaning without any human intervention and full autonomous driving? Well, if it's realized, I think it needs at least 5 to 10 years. My autonomous vehicle is between level 2 and 3. And if you use smart control function, my car can slow down or sometimes speed up, and with a slight signal from myself, the car does everything by itself. And that level of autonomous vehicle is already available in the market, and it helps great convenience and efficiency of my driving. However, to move on to the full autonomous driving with the existing technology, it will cost astronomous amount of money, and can it guarantee the safety? I'm not sure. But if we think about diesel and other gasoline cars, we still have accidents, and it sometimes burns for unknown reasons. And if you embrace these type of unexpected situations, yes, we can quickly realize the full autonomous driving. However, let's say grandma, grandpas, people, elderlies can get some benefits from autonomous driving, but they need to guarantee the safety. So that is how we develop our technology. Once we move into the era of the full autonomous driving, well, we probably won't even need a steering wheel. We could do our meetings in the car, and you can lie on your seat, maybe 180 degrees, fully flat, and you can even sleep during driving. And I believe our technology can contribute to realize such idea. And we already have 4 patents related to that. 4 years ago, we already registered, so consumers can enjoy vehicles with less accidents thanks to the technology, and that is the goal of my company. And all these autonomous vehicle manufacturers are working on their technology. And in Pangyo, Korea, we have a partner doing R&D, and with a 10 plus, 15 plus experience, all these doctors with their degrees are doing their research, because what consumers want is the genuinely safe autonomous vehicles not by driving themselves, and that's the direction of our technology.
Professor Dan, I would like to move to you once again, because it seems like AV is the future. Will this bring a better world? Do we really? Do you think let me pose that question in a different way. Will the world be better with AV? And what is the goal of having AV, do you think?
Well, the world will be safer with full-blown capacity of autonomous vehicles on the road. I do believe so, and I think it should be our direction for the long term. And even though I think it's going to be a little while until we get there, but I do agree with the Dr. Maha Ashore's idea of installing or defining the certain region or area to be a public road where only the autonomous vehicles are operated on. What I'm saying is, for the certain sections of expressway or highway, freeway or whatnot, we can designate those areas or those sections so that the commercial vehicles fully equipped with autonomous vehicle functionality, we do give them a chance to be running in a fully automated way so that we can, how do I call it, accumulate more data and in a limited sense because it is happening only in the restricted area. But with this try and with these examples, a lot of consumers will develop their confidence in that autonomous vehicle functionality. And as we become more familiar or as we become more exposed to that autonomous vehicle driving situations, I mean, the market will naturally develop, even if there's a little bit of challenges out there still. But I think in that sense, I really like the idea of specifying certain areas for the autonomous vehicle compatible road or public road so that a lot of companies can put their vehicles on to test on. So I know that it's going to be a little while to see all the vehicles on the public road, but we will have to get there. And in doing so, we should be starting with a limited area where we can test out the autonomous vehicle with the actual consumers or actual business entities. So that's my opinion. Yeah.
Following up, I'm wondering, in a world with autonomous driving, will there be more or less cars, do you think?
I'm thinking about that situations with the autonomous vehicles, fully autonomous vehicles, fully populated among the society. I expect there's going to be more cars on the road because, you know, thinking about the cost of parking, you know, you have to pay $5 per hour or $10 per hour. I mean, in New York, maybe $20 an hour. I would rather let my AV, you know, moving around the city, you know, because I don't have to pay the parking, right? And the fuel cost is about $5. Then I would rather put it on the public road. So that's something that we really have to be careful. With the development of this AV, we may have to change our view in the controlling the traffic patterns in the downtown areas. Some people think since we're going to be sharing those vehicles among many people, so we are expecting to have lower numbers of vehicles driving on the public. But I see the future driving patterns completely different from now. Because with this AV functionality fully implemented, do I want to pay $20 parking fee or $5 fuel, which is, I am assuming, electricity, $5 fuel, and I'd rather run my cars on the street since no driver is required, right? So in terms of managing the traffic in the downtown area, we may have a serious difficulties. We may experience serious problems. So that's what I think.
Okay.
More cars on the road in the future.
Wow, okay, thank you very much. We're having some questions come up on the board, and I will try to phrase it in a slightly different way and give it to our panel discussants. Ali, there's a question from J.H. Kim, and the question is basically about what do we see as the obstacles for mass rollout of autonomous vehicles, and for example, how do you see the role of policies by the government, policies and regulations, I guess?
Very good questions. So there are challenges both on the technology side, as was discussed earlier, but also on the business models as well as regulation. For regulation, some countries, Korea, for example, but also some jurisdictions in the US, as well as the European Union and Japan and Singapore, they have actually taken a good framework. They've already planned. So for example, in Japan, even for ADAS, there's now regulation in place, and automakers have to submit their vehicles to be certified. In the US, the tricky situation has been that the federal government so far has actually not regulated EV deployment, and this has been a contentious debate in the country. There's some who think this is good. There are others who worry that as different states have been setting their own regulations, so for example, California has fairly strict regulations around testing, whereas places like Florida don't. And this is creating a challenge for both incumbents as well as startups around having to deal with different regulatory framework across even state lines. Long story short, the two schools of thoughts are the side that says like we don't need regulation argues that the technology hasn't been developed yet, so let the technology developers develop it first. This is particularly Elon Musk would be a perfect example of proponents of this approach. There are others who point out that you can't use public streets as your demo site essentially, and the national government should take a view and regulate it. And if you look at around the world outside of the US, most regulators take that approach. Most regulators want to ensure that safety is in place. On the global level, the UNECE, which is the international body that sort of sets homologation rules from vehicles, they do have a technical working committee on this issue, and they've made quite good progress. But still, there's a lot of room for improvement on this front.
Ali, thank you for that. You know that there's going to be we need a lot of infrastructure other than within the car, but also outside the car to make sure that AV works as well as it should, which means each country, when they adopt AV standards, there's going to have to be a very uniform standard so that a car manufactured in India will operate very well in Korea, and something that's developed in Canada should do very well in France. Okay, how do we? Is there a movement around the world to try and bridge converge the technologies? And this is a question I will also ask Maha. Okay, so first Ali.
I'll keep my answer short. I believe Dr. Asher will have a lot more details. In short, yes, there are initiatives around standardization. The tricky point on here is, unfortunately, the efforts around standardization have now been caught up in the geopolitical tensions. So increasingly, it seems more likely that you're going to have a Western standard and a Chinese standard. And where it comes to things particularly sensitive information such as HD mapping, there is already many countries have regulations around where the data needs to be stored. And by the way, this is not just a China issue. So many in our audience probably know that like you can't use Google Maps very well in Korea. If you want to use Google Maps for driving in Korea, for example, you can't do it because Korea has very strict regulations around data sets. So as a result of that, because Google Maps uses servers outside of Korea for traffic information, you can't get that on Google Maps here in Korea, whereas you can do it in other countries. So those sort of geopolitics as well as data protection rules means likely we're going to end up with not just one standard, but probably a family of standards applicable to each region.
Wonderful, thank you. And we're running out of time, so Maha, very quickly, please.
Sure, yeah, definitely. I think hardware-wise, all cars will be compatible to work in any geographical location. It's going to be a software upgrade. Okay. And I believe it's going to be a combination of the connectivity network, and especially the edge processing services, as well as the centralized compute.
Beautiful. And my last question will be for Chairman Kang. It's from the floor from Jay Choi. And the question is, there are companies, small, medium-sized companies that want to work with the likes of Edison in developing for the technologies. What is the best way to do so? Very quickly, please, because I've already run out of time.
If there's anyone who would like to work with us, especially component parts, you're more than welcome. You can come to our official website and then you can find the contact information of the purchase department. We have factory in Kunsan, for example, and those suppliers mentioned that once they met e-vehicle company, all internal combustion company related suppliers will die. But there are a lot of common areas that the combustion engine related components can also create something similar between traditional combustion engine car and the e-vehicle. So the existing suppliers of auto components can always join this e-vehicle industry, and there will be better collaboration because sometimes those companies have technology but do not have the manufacturing capability. Thank you. Can I add one more? There's an association of a vessel in Korea, and then once you are certified, you are available for the overseas sales. Unfortunately, for the case of the automobile, we have to be certified by each and every country that of which the market we want to enter. For example, if you want to go to the U.S. market, you have to get certified by the U.S. But vessel is different. So hopefully this can be changed in the auto industry.
Discussion to the speakers and also to the floor. I would like to hand over the microphone to Dr. Dan Choi.
Yes.
Can we have 10 minutes break, please?
Of course. That's what I was going to mention. Okay, thank you very much for your wonderful panel discussion, leaders. And Maha, I'd like to make sure that, is it okay to resume your speech at 10:25?
Yeah, sure, definitely.
Oh, I'm sorry,
No
6:25 your time.
6:25, yes,
Okay.
I understood that. Yeah, definitely.
Then we can have 8-minute break. All right? So why don't we resume our next session starting at 6:25 San Francisco time, 10:25 Seoul time. All right? Let's take a break. 8 minutes. Hello. I think it's 10:27, almost 10:27. So I think we have to resume our session. And oh, can you change the screen to the Zoom screens? Because I don't see. Okay, I see you now. Okay, we're back.
Yeah, I
Okay.
am back.
All right.
I'm here.
Okay. Now, let's move on to our second keynote speech, again by Dr. Maha Ashore. This time, the topic of the speech is Future of Connected Autonomous Vehicles in Smart Cities. This is exciting because we're now talking about the future. Please welcome, again, Dr. Maha Ashore.
Thank you. Let me share my screen again.
Yes, I see you.
Here. Perfect. Can you see my screen now?
Yes.
Perfect. Very good. Wonderful. So let's start going over the outline. So this time, first of all, I want to thank our previous panel chair, President Eugene John, for an excellent discussion, questions, and the panelists for addressing his questions. So this one will basically try to paint a realistic picture. And unfortunately, it is a puzzle with so many different pieces. And sometimes these very small pieces, if they're missing, you really cannot see the whole picture. So I hope with this presentation, I'll share with you the different key puzzle pieces that are essential to make this happen in the next few years. So I'll start by talking about automotive future in general, the role of 5G connectivity. Yes, 5G is essential to be able to make this happen. And then briefly speak about the V2I, V2X, V2B, and then bring everything together to define the next paradigm shift that I've been talking about. I'm not going to go over the slide since I covered it in the previous discussion, where I highlighted the necessity of the ultimate 5G high capacity, secure, reliable, and low latency connection in the implementation of AV in smart city. So let's basically go over the different building blocks. Compute. We all know that cloud computing is going to be a driving factor, both at the edge in a distributed AI and machine learning infrastructure, as well as in the software stack inside the car for the sensor fusion capability. The connectivity, again, as I mentioned about productivity, President Yoon mentioned why AV. AV is because we want to increase productivity of people. Instead of them driving during peak hour, they can drive during less peak hour and still do conference calls, still do work during these autonomous vehicle mobility as a service. So connectivity is going to be essential as well. And of course, mobility as a service. And as you can see here, MetaWave is addressing every single sector with the Spectra radar for autonomous vehicle, the turbo and clone, repeaters and relay for 5G infrastructure, and then the AWARE for AI and machine learning. So just kind of to set the whole picture, the high level picture. So L4 to L3 requires driver in the loop. That means the driver is behind the steering wheel and can take over the control of the car when needed. L4, L5 is basically the driver is outside of the loop, where the liability now falls into the mobility as a service or the OEM tier 1 that provides these vehicle to the consumer. I'm not going to go over all of these safety standards, but it's extremely difficult to go from level 2 to level 3 and level 4. I think level 5, in my opinion, is not going to happen in my lifetime. That's kind of a long-term mirage that will happen maybe when we have quantum computing operating at the edge. So let's understand the EV factor, because as you know, electrification is something that's going to be driving AV down the road. We saw these two EV and AV going in parallel a few years ago, EV now is way ahead with so many car OEMs releasing more vehicle on the market, and AVs kind of tagging along. And this gives you an example here of how many cameras and LiDARs and radars are currently on these vehicles, from a level 2 like Tesla to level 3 and 4 like Waymo and GM Cruise. So the more hardware sensor you have, the more reliability and safety you can need at the, of course, cost of the data processing and the complex sensor fusion stack that you have to build within the system. And the common denominator over all of these hardware and software capability is power consumption. Maybe cost is not going to be an issue initially, because safety is always going to be number one. But power consumption is going to be essential, because most of these EV cars, they want to still operate at longer range driving, 200 and 300 miles per battery charge. Just to give you an example, for a Tesla Model S, which I have, you can see how the range actually varies with temperature. So the colder it is, the lower range that the car will have. And obviously it's because of the battery, because of all of the different chemicals that goes inside the battery. Also speed, the faster you drive, the lower range you will have. So now if you have an AV car, so put Tesla aside, think about now an AV car with a very smart brain, it can really operate in an efficient mode all the time. So it doesn't have to accelerate all the time. And since it maps, or it has these digital maps in its sensor fusion or distributed at the edge compute of these 5G networks, it can basically optimize its driving capability. So this is why I'm very hopeful down the road, the more and more AV cars we will have on the market, the more efficient these vehicles are going to have, and its impact on global warming will be less predominant. So let's talk about 5G. And I think this is where people sometimes they forget that AV is not going to happen as just one car driving autonomous. This mode has to operate, but it will not operate 100% of the time, probably 10% of it. Most of the time, especially in dense urban environment, which is the most complex environment, you're going to rely on the infrastructure around you, on the vehicles around you to basically augment your perception. And I think this is where, once we pass that hurdle, we will see a huge acceleration in the rollout and in the adoption of AV. And you can see here the dotted line, and I circled these two areas. Everything else here is solid line, happens in a centralized AV car. And everything in the dotted line, you see here V2X, but it could be V2I, it could be V2V, is basically happening outside of the car. So it's a very complex system, and software is going to be so critical in terms of implementation. Just Tesla recently announced that they released their own microcontroller for their sensor fusion system. And it's because they require a huge amount of complex signal processing in the digital domain at a much lower power consumption. We also mentioned how Qualcomm is getting into that space too, with its microcontrollers, and how Intel is pushing its own microcontroller with Mobileye. So software is going to be a driving factor. And as I mentioned at the end of panel one, that hardware is going to be a common denominator among all the cars that can operate everywhere, but the software is going to be the enabling factor for AV. And having a hardware in the loop or hardware out of the loop are one of the key factors. So let's take a couple of examples. In this case, you have our beloved red light, but eventually those red lights can just be transmitting some signals. So the car doesn't even have to see the red light. It can just get a signal that it is red or green or orange and react accordingly. And I think sooner after that, you'll see that these red lights don't exist anymore. So you really don't have to wait on an intersection when there are no cars. You'll just basically go through, enabling a much less congested road. So that's one example. The other example, like if you are driving and you have an ambulance going through between lanes, that signal is already being distributed to the nearby adjacent cars, and because of B2V communication, the signal is already propagating across the whole adjacent car structures. Or if you have what we call black ice, which is extremely dangerous on freeway, if one car goes over it and detects it, it already can communicate that with the other cars. So these are kind of the different pieces of the puzzle that are needed to make AV happen on a much larger scale. So let's now zoom in into that network that will enable this capability. As you know, CV2X is a new standard that will be predominant for V2V communication, and security is always going to be a key. That's why 5G networks are quite secure. High capacity and low latency are essential for the scalability of these networks, especially when you think about all of these IoT, you know, on the traffic signal, on the sign, the road signs, and so forth. So all of these IoT, they require also connectivity to these networks. So always go back to the theme that we set earlier in this discussion, which is global warming. As we know, in 2010, Cisco mentioned that the amount of data processed per month are in terabytes. In 2015, we're at exabytes, where exabytes is a much larger number than a terabyte. And that's only 2015. So the numbers now are much, much higher. And then if you just also take a look at the difference between the 4G, okay, 1 exabyte is basically 1 million terabyte. I was looking for that sign. And if you take a look at the difference between 5G and 4G LTE, which 5G now is accelerating, and I believe China is going to release its, I don't know, that they're talking about millions of 5G infrastructure radios in the next couple of years. The densification of the radio, because that's much higher frequency, is 1,000 compared to 4G LTE. So the question is, how much of carbon footprints these networks are going to have an impact? Because when you talk about green energy, don't think just about the car itself. You have to cover the whole ecosystem. And this is where exactly MetaWave is playing a big role. Instead of doing the brute force way of installing a radio in every single intersection, you can actually just use a very low cost, sometimes zero energy relays to increase the coverage of this network in a more reliable way. So thank you. So I want to welcome you to MetaWave 5G solution, where we are building these passive reflector and active repeater to increase the speed and the bandwidth, eliminate all the dead zone that could currently happen in these high frequency millimeter wave 5G networks at a very low cost, very low power consumption, and very low latency applications. I'm just going to skip a couple of slides since I've already covered those previously. So what are the other 5G applications, especially at the edge compute? So we talk about the first one, which is autonomous vehicle. You also have the home connectivity and security, which is a much larger total addressable market. You have also the office, the smart cities, and public health at $1.7 trillion total addressable market. The factories and operation, these are all the industrial automation at 3.7 trillion. So it's, that all of these applications are happening because of the high capacity and low latency of these networks. So what are the products that we have currently released to the market? The first one is a reflector. So it's a smart mirror that you can hang. It looks like a picture. It has zero power, does not require any wiring. It can extend the range of these base stations and these radios by 50 meters with zero delay, zero OPEX, providing an increase of gain up to sometimes 50 dB. So far, we're very proud to be the only company that is offering this line of product, which is extremely critical to enable a much faster rollout of 5G. We also have released the turbo repeater, which is an active version of the passive reflector now that you can increase the range by 250 meters. So instead of putting 5 radios in a parking lot, you just put 1 radio, 1 turbo, and you have full coverage of the whole parking lot. This was just one example. And a very low delay because these are all analog repeaters. One thing I want to point here is that unlike 4G LTE and 3G, where it was more consumer oriented, as you saw, the pendulum of the return on investment was going towards the consumer. I think 5G, and exactly because of the previous slide where I mentioned all the different applications from industrial automation to smart city to autonomous vehicle, the pendulum basically is geared towards the industrial, the enterprise, market first before it goes into the consumer. So we work on a big licensing base for the 5G. We announced a commercial agreement with one of the top Japanese supplier and network planner for top Japanese carriers, but we also work for indirect sell. So here I just want to show you a video that basically tells you a little bit more about, and this was done by KPMG, where it gives you an idea about how this is going to work down the road. And it will show you also the idea of having these hybrid infrastructure for AV and then regular driver assist cars. So I'll just let you watch it. Actually, there is audio here, but I disabled the audio. So here you can see that school students, they go there, they can still do their homework as they're driving to home or to their next stop or play games. This is where I said productivity, and also this is where I said that actually, even though you're going to have more cars on the road, but you can have less congestion because everything will be planned ahead of time in order to minimize this high level of concentration of vehicle. All right, so getting to my last slide, putting the whole thing together. Remember at the beginning when we were mentioning the connectivity, when we mentioned the mobility and then the compute, how these IoTs, 5G infrastructures, and self-driving cars, smart cities, and AI and machine learning are creating smarter cars, smarter road, smarter cities and network. And we're very happy, as I mentioned to you in my previous presentation, how the Spectra radar fills the gap of that missing sensor to achieve higher level of safety, and how the machine learning and AI provide these early labeling of object to the sensor fusion. And in this presentation, I shared with you how our turbo and clone 5G solution can actually expand the network of millimeter wave 5G to enable the rollout of these networks on a much faster pace. Thank you very much.
Thank you. Thank you for giving us the insight for the future. And apparently, I mean, it looks like 5G, I mean, infrastructures are going to be very, very important in terms of future implementation of this AVs. Okay, so we are right on time, I mean, in terms of schedule. I'd like to ask Dr. Ali Izadi to lead the second panel discussion of the day. As we all know, Ali is stationed in Seoul, Korea, and he is serving the community with all kinds of nice data. He is working for Bloomberg NEF, and then he's here to help us. I would like to ask Ali to lead the panel discussion, please.
Thank you very much, Professor Choi. Really appreciate the kind introduction. And it's my pleasure to moderate the second panel. And the focus of our panel will actually be picking up on some of the themes that Dr. Yoon discussed in the first panel discussion. So yeah, I know many of you had many more questions around AVs, so now we'll have an opportunity to discuss those. My panelists for this session, we're very lucky to continue to have Dr. Ashur join us, as well as Professor Choi and Dr. Yoon. We also have a new panelist, Mr. So Kim from LG CNS. I'll actually give an opportunity to Mr. So Kim to introduce himself and LG CNS's activities around smart cities. So Mr. Kim, the floor is yours. Please feel free to start.
Well, thanks very much, Ali. Well, you might remember me previously doing a different job, but now I'm doing LG Smart Cities Global Expansions. Especially for today, I'm here to explain LG's two major smart city projects and how they can connect with the mobility. So to do that, I would like to go through the short slide that I prepared. Should I just press button? Okay. I think we'll present from here. Yeah, because you know, smart city is not just the LG CNS interest; it's about also whole LG group. So let me briefly explain you why LG is doing and what they are doing, who they are. Because you might remember LG is just producing home electronic good and home appliance and TV or maybe etc. But whole LG Group have focused on smart city as their next new business model. Well, LG is basically located everywhere in the world because LG is also one of the biggest companies in South Korea with the Samsung. One of the key factors that I want to emphasize here is LG is trying to use whole their group power to push smart city business with the global partners. This is basically the global project they've been doing now, already done, they are still developing. And also this is my role to develop more smart city project with the global partners. And also that's why I'm here today to explain you the Korea LG's two big smart city project. You might not know about this, but most of Korean people are very familiar with the project. But Korea have two major national pilot projects in Sejong City and the Busan City. It's called the Sejong 5-1 district and the Busan Eco Delta City. LG won both of them. So LG lead both projects, so which is a huge project. It will change smart city paradigm for next 10 to 15 years. Well, I'll go a little bit more deeper for the next following slide, but not only national pilot project, Korea also have a smart city challenge project, and also other small projects around the nation. This is basically Sejong Smart City's big concept. It's one of the biggest projects Korea ever done nationally. But one of the main targets is we have to reduce 30 to 40% of energy in this smart city. But LG tried to focus on using mobility service to reduce energy. And there will be no normal car. There will be only autonomous car. There's only electric vehicles will be exist in Sejong Smart City. It will be highly restricted to bring normal car to this city. And LG is actually designing all different service model with this new paradigm, which is there are 7 initiatives. This have to be, established in Sejong Smart City, and mobility is the top one, because as you're already familiar with that, building and mobility is using most energy in the city, and they're just trying to focus on mobility in the Sejong Smart City. Busan is also the second biggest project. It has slightly different aspect, but also mobility is a very main concern that LG is trying to do. Here there's 10 different initiatives. So initiative means there will be 10 different service model will comes out with this initiative, and also works with the application. Application means partners locally and globally. Whole LG Group, especially for the LG CNS, is leading smart city in the several different aspects. This is, but basically they have a platform called City Hub. So Sejong and Busan and all other smart city that LG is doing, they are using LG's smart city platform. It's a private platform, but it can be applied many different things that they have. As you can see, there's 5 different main services this City Hub can contain. But mobility is the main thing, because the mobility and building consume most of energies. Yeah, that's a short introduction that what LG is doing. And as we are also focused on how mobility will, connect with the smart city project, and I'll also answer if there's any question from the Ali, then how we can connect mobility with the smart city, the two biggest national projects in South Korea. Thanks, Ali.
Thank you very much for the insightful presentation. So we're going to get into the panel discussion in a moment, and we will be following on some of the earlier discussions that we had in the morning. Before we get into the discussion, what I thought I'll do is I'll share a few slides which hopefully complement some of the topics that were discussed, including the presentation by Dr. Ashur, to show you a little bit what has been happening around autonomous vehicle development over the last 5 years. And to do that, I thought I would actually use pictures from the Consumer Electronics Show, CES, in Las Vegas. CES is sort of probably the best known event around the world for showcasing new vehicle models. Interestingly, even though it was a Consumer Electronics Show, it's now more or less has become the best place to feature new vehicles. If we go back to 2016, at that time, there weren't that many display cars. The most exciting presentation at CES in 2016 arguably was by NVIDIA CEO Jensen Huang, who was showcasing some of the tools that they had developed to help for both simulation as well as processing of sensor data for AVs. A year later, in 2017, there were a lot more display cars. This one that you see on your screen is one that BMW was showing. At that time, BMW had signed a partnership with Intel-owned Mobileye, and they were saying that by 2021, so 4 years later, they plan to launch a fleet of fully self-driving vehicles. A year later, Toyota took the stage with unveiling its e-Palette. They announced many big partnerships around e-Palette, including with Didi and Uber. Toyota at the time was saying that 2 years later at the Tokyo 2020 Olympics, they would be using e-Palettes to shuttle spectators, athletes, as well as any sort of logistical goods transport needed in the athlete village. Of course, unfortunately, the pandemic delayed the Tokyo 2020 Olympic. When the Summer Olympics took place earlier this year, Toyota did use the e-Palette. Of course, there were no spectators allowed. And unfortunately, even though the usage was limited down, they still ran into one accident. This was very unfortunate, and this accident, by the way, was not really so much of an issue with the autonomous system features used by e-Palette. It was actually caused when one of the manual operators was using the vehicle, but still it generated a little bit of negative media attention, and it resulted with in Toyota suspending the trial for a little bit, although they resumed it again. A year later, the hype had died down a little bit, and actually the most notable interesting announcement was this new grouping of companies, both very large incumbents such as Volkswagen Group, Audi, as well as some of the startups such as Voyage and Waymo, who were getting concerned around some of the confusion that the general consumers were having around AV language. So they wanted to launch a new initiative to help with educating consumers around autonomous vehicles. Their efforts are primarily focused on the US, but some of the material that they produce is actually very useful globally, and I would encourage our audience to look up this association, Partners for Automated Vehicle Education, because I think actually some of the material they produce would be quite useful here in Korea as well. In 2020, so the last physical CES event, there were still a lot of display cars by automakers, but the most interesting one was actually the one that Sony showed, which Sony was trying to highlight some of the offerings that it is developing around sensors and processing technology for AV developers. What was really cool about what Sony showed was actually the car looked realistic. At the same event, this is the one that Mercedes was showing, and Mercedes was showing a car that they developed in partnership with the Avatar movie director. So some of you may be familiar with that one. Purely personal opinion, I thought Sony's car was a better way of showcasing AV technology because it looked like a real car, whereas this thing seems really something out of a Hollywood movie studio. And then this year, of course, CES was virtual, so it was a lot harder for companies to showcase physical technology. This was the attempt by Cadillac to showcase its sort of PAV pod, so PAV meaning personal autonomous vehicle. But again, it doesn't really look like a real car. The reason I thought I would put this up is, as Dr. Ashore talked about earlier with the Gartner hype cycle, for AVs, there's a sense in the industry that 2018 was sort of the peak hype, and now we're sort of entered the trough of, at least when it comes to autonomous passenger vehicles. There are, of course, contrarians, and we've already mentioned this before during the event today. Elon Musk has been maybe not necessarily the biggest, but certainly the best known proponent of autonomous personal passenger vehicles. Back in April 2019, when Tesla was holding its first Autonomy Investor Day, he also made this pronouncement that by over a year later, so basically by 2020, Tesla would have over 1 million robotaxis. Now, it's already over 2 years since this announcement, and of course, there's no such thing as over 1 million Tesla robotaxis on the road yet. You may think I'm being quite cynical, and to be fair, there are actual autonomous vehicle testing taking place all around the world. What this chart is showing you is data from California and Beijing around level 4 capable test vehicles. The reason we're showing data from California and Beijing is these are the two jurisdictions that actually have very good requirements around public disclosure of data by developers. There are other places such as Arizona and Florida where there are hotspots for AV development, but unfortunately, in those cases, there's not a high requirement for public data disclosure. If we take the data that from where there has been public disclosure and analyze it, we can start to get a little bit of a glimpse around how the technology has progressed. What this chart is showing you is the disengagement events per 1,000 miles of testing by AV vehicles in California. What disengagement means is essentially when either the autonomous vehicle software disengages automatically because of either a glitch or an unforeseen circumstance that it cannot handle, or that if the vehicle has a backup driver on board, that human driver has decided to interfere with the AV system operation and take over. If we assume every disengagement event would lead to a crash, then the line at the bottom, that average human crashes per 1,000 miles, that shows you on average how good human drivers are. This is, by the way, the data for the US. So if we go by that metric, that basically means the best developers, at least based on this public data, which are GM Cruise and Waymo, they're about 40 times worse than the average human driver based on the latest testing data. Now, of course, not every disengagement would lead to a crash, And also the way these disengagements are classified is a little bit not consistent by developer. But this is unfortunately the sort of not the best way to compare, but sort of the only way right now we have around being able to compare based on public data. The other thing we could look at, of course, is investments in the sector. And what this chart is showing you is venture capital and private equity investment into areas around vehicle automation, connectivity, related chips and maps, as well as mobility services, so ride hailing and car sharing. And again, you can see that there was a lot of investment around 2017, although most of that was in mobility services. On the vehicle automation side, despite some of the negative news that we've seen, actually you can see that the investments has continued to grow. So that purple bar that you see, actually the first half of this year was a new record. So it means that at least from the investor perspective, there's still a lot of room for investment and opportunity in this sector. Hopefully, this gives you a little bit of a grounding around at least what has been happening over the last 5 years. And with that, I'm going to now invite my panel to continue the discussion that we had earlier on. I would like to continue with the question we were discussing earlier around what are the real challenges with AV development. So Dr. Ashur, if I may invite you first, and you referenced the Gartner hype cycle. In terms of the challenges that we see around AV development, in your view, is it still mostly around technology, or are the business models and the legal issues that we were talking about earlier, are those also major challenges already today?
I think it's more technology. We're still in the technology development phase. It's very clear, both hardware and software, they're going in parallel. And at the end, in my opinion, you can start by using huge number of sensors, like I showed Waymo as an example compared to cruise. But once, in my opinion, that the software stack is mature, the AI has matured in terms of data collection, in terms of perception, we will transition then to municipality, regulation, insurance, liabilities, and all of this, which is what I said is going to take a much longer time to resolve these issues. But we're still in the technology development phase. And that's why MetaWave exists today, to fill in one of the gaps that exist in terms of the primary sensor.
Thank you very much. Dr. Yoon, if I may bring you to the discussion, and now it's my chance to put you on the spot. so you, in the first session, you actually expressed potential reservation around riding on AVs. So considering Dr. Ashur's answer as well, let's say you were actually in Pangyo City, where there's already AV shuttle testing happening, and I believe, Mr. Sokin can confirm later, there are plans also for similar deployments in Sejong City as well. If you had the chance to ride one of these autonomous shuttles right now, would you do it?
Thank you for that question. So Ali, I think I've ridden in one of these driverless things recently. I think it was in Incheon Airport, where we have to go to one of the terminals that are far away. And I noticed as the train came in, there was no one driving the train. And I was a little bit frightened to get onto that train, but it was only a 2-minute ride. And throughout the whole time, I was holding on to the bar and wondering what kind of disaster would fall. Nothing happened, I'm glad to say. I think some people, like me, we have innate fear, okay? And the more we know, the more scary it is, it seems. And so I'm still skeptical. I don't know if I would go to Pangyo and ride on one of those things. And to me, to try and rationalize what my fear is all about, I think that AV requires a large amount of technologies and other things to converge together to make it perfect. Okay? If it's less than perfect, then it's dangerous. Okay? As a pedestrian, I don't want to be walking around when there are driverless cars talking to each other and not regarding traffic lights, for example. Okay? They may be talking to each other, but they're not talking to me, right? Unless I'm connected as well somehow. I think there are, some people mistake good technology for perfect technology, and they think they can, drink beer and fall asleep as the car is moving along because they put it on, some kind of assistance, yeah? So, which they believe is full driving, self-driving. So I'm very concerned about where we are technologically and how safe and perfectly well put together it is before we say, yeah, this is okay for everyone. And what is acceptable, let's say, in Korea may not be acceptable in Italy. The culture, our tolerance for security and safety is probably different across different cultures.
Thank you very much, Dr. Yun. Professor Choi, if I may bring you to the discussion, taking into account the response from Dr. Yun and Dr. Ashur, what's your view, particularly in Korea? Do you think there is a technology misperception around AVs?
Well, we're working hard on it, that's for sure. And as I mentioned before, the ultimate goal is to have AV everywhere on the public road. But if I had a chance to get on board fully automated vehicles, I would be more nervous than driving it myself, at least for the first few, I would say, few months. But once I get familiar with it, I dare to say that I would be comfortable riding in it, because I would know what's going to happen. I would know how these vehicles are going to maneuver around and things like that. But still, I don't think I will let it drive all by itself. I mean, I will be there holding my steering wheels right around here, okay? But in terms of technologies, I think hardware and softwares are getting there. But it takes definitely longer time than we expect to make it complete. I don't know if my answer is going to be good enough to your question or not, but that's my perception, yeah.
Okay, fair enough. That's very good. Mr. Kim, your views?
Yeah, I have a slightly different view with Professor Choi, because now my task is we have to have autonomous vehicles in Sejong City within 2 to 3 years, whatever technology is ready or not, whatever people are scary or not. That's our task,
right?
Yeah, so we will think about how we can do it, but we can't follow Elon Musk's thought. We can't let every car is Tesla. So every car is Tesla, maybe it will be possible, but we are not able to do that. So what we thought is we discuss what is the most fear factor for the people for the autonomous vehicle. As Dr. Yun mentioned, he's holding a bar, yeah? Speed is also one of the fear factor for the autonomous vehicle, for the generally speaking, according to survey that we did for the other cities that we did before. So we basically divide road into 8 different sectors. So normally in Korea's major city, you will see the 4 road each side. But we divide, if you come to Seoul have a bus line in the middle, and there's other lines there. We try to divide cars based on the speed. So autonomous vehicle will follow the main 2 roads. There will be another car or 2 lines for another vehicle, and the last line for the personal small EV and small scooter or small bike. So that's our sort of initial idea how we can establish, how we can do autonomous vehicle within the 3 years, which is let people less fear for this AVs moving. So we divide the road into different sector, so try to make it possible. So that's what we're trying to do. I think you will see that strange road within the 3 years in Sejong City, because that's how we actually design the infrastructure.
Ali, may I jump in? Okay.
Sure, of course.
Because whenever Sejong City comes up with something, I become a little bit alarmed. Okay, and you know, Sejong City has always seems to move on a time clock that is unrealistic. The government moved there when it was not ready. The apartments were not ready when people had to go in. They didn't have hospitals. They didn't have supermarkets. The whole planning behind Sejong City is actually one big disaster. I was told once I go there that, you know, I should park far away and there would be green cars and it would be a green city. Sejong is not a green city, has never been, and I don't think we will achieve that. So when we talk about Sejong City being smart, I question how smart it's going to be. Sorry, Dr. Kim, okay? And to go ahead as regulators and policymakers do and say, we will have AV in a certain amount of time when the industry does not think it's ready, that is that's typical of Sejong City, and I'm very, very frightened at this stage, once again.
I will give an opportunity to Mr. Kim to respond, but Dr. Yoon, just my own personal experience, and I'm not involved in Project Sejong City, I think your impression may be a little bit dated. I have been there quite recently. They have a lot more nicer restaurants, some better than Seoul.
Oh, that's today. That's today, Ali. You know, when it first opened, Sejong City was just a dusty a couple of buildings and no parking. It was just terrible. It was very badly planned. Yeah, I would say it was not the smartest city in Korea, probably one of the dumbest cities in Korea. That's my criticism. I hope there are no government officials here, by the way. Yeah.
But I think that's something that we can take advantage of when it comes to implement our AV technology on the public road. They set up their goals in a unrealistic timelines, but this would be a good playground for us to jump in and then join the ride along with their schedule. You know, put whatever we have on the road and then let them try. So this, it has a goods and bads, I think.
All right, may I jump in as well, Ali? Thanks, Dr. Yoon, Dr. Choi. Yeah, I basically agree with your ideas, and we also have to think, we have to meet the public's expectation, because whenever we say AV, normal public, they don't really care about how technologies develop, but they already sort of heard about it. They already thought, okay, this will be happening in my city. Then the company like us, we have to try to figure out how to make it possible. To meet this satisfaction, because this also generally people are already increasing their expectation, because you know, people are watching TV and YouTube, but in some country there's already AV. What about the Sejong? They say it's the best smart city, but where is AV? Yeah? So that's sort of our task. Have to meet the people, because we are a company. Company have to sell the product. Yeah, how to sell the product? We have to meet it. People's general public's needs as well. So that's why we actually come up with the idea with the road division, making road different with the other roads, so make it possible in the short term. So, but yeah, hopefully the Sejong 5-1 is one of the sector area for Sejong Smart City. There's also another area, the Sejong, but the area the LG is doing is a sort of pilot area. So this is a prototype and pilot area. This will be expanded for the whole Sejong City. Also, we have two different pilots, which is in Sejong and Busan. They have a different aspect. So hopefully we can meet this, general, needs and the people's, request with the technology exists now and technology will happen in 5 to 10 years. So hopefully it'll be better city from now on because LG's jump on. Yeah.
I think this project is something that Metawave should jump on and then get your technology be tried out there. Okay.
Thank you. Mr. Kim, actually, if I may ask a follow-up question, what type of AVs are you considering for Sejong? Is it shuttle buses, personal vehicles, commercial vehicles?
Yeah. What LG is doing well is a platform that I actually briefly mentioned of City Hub. They are producing a platform for the city, so application can be various. It doesn't have to be only Korean application. It can be also applied for the other application. So we are trying to we have a platform, we are trying to design the service model for the city. For the cars, which brand you'll use, we don't know yet. It will be designed with our technology in the development and those people's needs and the range, purpose. But one thing we can make sure is in Sejong 5-1, you can't use normal car. So you can't drive your car to your home. You can't drive your car to your shops. So we have to find a different solution to make it possible. So that's our biggest task. So of course, Metawave can always jump on, and we need a lot of good company to work together because LG is not producing any car. Yeah? Hopefully in the future, but not yet. So that's why I'm looking for, yeah.
Great. So on that note, actually, Dr. Usher, if I may bring you back into discussion. In your presentations earlier, you alluded to the different applications of autonomous vehicle technology, so from personal cars to trucking and platooning and other sort of applications. Are there some that are easier and quicker to implement compared to different kinds of applications? Or are they all equally difficult?
Yeah, I think AV trucking is much easier because the paths are very well defined. You know where you are picking up the trailer, you know where you're dropping off the goods, and you typically operate on roads that are not congested. So in my opinion, AV trucks are gonna basically thrive in the near future compared to robotaxis or mobility as a service. The other one is the delivery of goods, the last mile delivery. As you know, with COVID situation, the delivery of goods has been hindered because of lack of drivers, human drivers. And these are small shuttles. They deliver hot food or they deliver packages, and they don't have any driver. They operate very slowly. Some of them, they can even go over humps to get to the consumer delivery area. So I think those two things are gonna go first, and that will increase the curiosity of the consumer that if this really happen, I will be able to go on one of these cars. And if these cars offer exciting services, like let's say I drive on this car and it shows me as I drive around the sales or the opportunities to go into movie theater for some discount. Typically today you have it on your cell phone because you have to subscribe to these services. But now as you drive the car, you see all of these cool things happening to you. And this is where you're gonna attract more and more, especially young people to adopt this technology. It's always gonna start with the younger generation to adopt this technology. And I believe safety is always going to be the #1 criteria. Like if you take a look at just Cruise and Waymo, how many crashes did they have over the last 5 or 10 years? Very few. You can count them on your fingers, right? So don't look at Tesla because this is not full autonomy, right? So this is why I'm very hopeful. This is why I believe the technology maturity is going to happen in the next 5 years, and then we can go over the mass rollout after.
Thank you very much. And if I may link this, your response to this question around timelines. So if you're looking at the next couple of years, what key technologies do you think might be potentially realized, and then what applications may be enabled by those technologies?
In terms of autonomous?
Yes.
So I'm talking about the hardware and the software for the centralized or distributed. There are, so as I mentioned, a lot of puzzle pieces that takes to build this picture. So do you want me to focus on one specific area or go over the whole thing in general?
I think maybe let's start with the general and then we can get to the details. Yes.
Yeah. So of course, it all starts with the hardware. It all starts with the sensor and also with the control, the actuators, how do you stop the car, how do you shift the lanes and so forth. So it all starts with the hardware. And I think there is a maturity level that's coming along because of the billions of dollars being invested, especially in the camera and LiDAR. Unfortunately, radar is lagged behind because it was dominating by the tier one. This is why you see startup like MetaWave try to excite that market too, especially with our IP portfolio. So once you have this done, of course, the sensor fusion, the perception engine, centralized compute inside the car takes over. But that's really dependent on your sensor. So if you build a brain that operates with 32 sensors, it's not going to operate when you have 5 sensors. Do you have to start from scratch? Maybe. So maybe there is a delay. And maybe this is where Elon Musk initially was right, is that he said he doesn't want to have a LiDAR. He believed that camera is good enough. And of course, he already has radar on other cars. So I believe the hybrid camera and radar is going to be the right combination. And we see more and more EV cars are adopting these kind of platform. The question is that maybe 3 sensors on the front, 3 sensors on the back, maybe 2 sensors on the side to have a full 360-degree view will be sufficient to operate the car in all kinds of modes, on the highway, in urban dense area, in the parking lot, and so forth. Now the most challenging part is outside the car, is the V2X, the V2V, and V2I. It's not there yet. You have many car OEMs looking at these CV2X applications. Standards are still pending. Interoperability is still not there. So that's going to take some time. And I think that's going to be the biggest missing puzzle to get over the hump of the technology. Once we go over that hump of the technology, it becomes just logistics. So I hope I gave you a picture of what is required to get to full autonomy. So probably 2 to 3 years, a little bit optimistic, but hopefully LG, with its very strong connectivity network, they can make it happen.
Thank you, and that's a good segue to bring in Professor Choi. So Professor Choi, Korea, of course, has taken the lead around deploying 5G. On CV2X also, there's been a lot of projects, and then just about 2 years ago, when President Moon was at a new Hyundai factory being that was being set up, he also announced this goal that Korea wanted to have 50% of new car sales be self-driving by 2030. Taking all that into account, do you see Korea making progress? Do you expect that not just on the ADAS side, but on self-driving, we see more accelerated deployment here in Korea?
I don't think we're going to meet that goal. 50% of AV by 2030? Impossible. But if you count the level 1 or level 2 autonomous vehicles, then we may be able to 100,000, maybe 200,000, or even 300,000 for level 2 AVs. So we have to, I think, realize what kind of sophistication is involved with the autonomous driving, what kind of level that we're expecting from it. Well, my personal impression is, I mean, somewhat similar to Maha's. Level 5, I hope it happens before I disappear, okay? But level 4, we're going to be there. We're going to be there within 10 to 15 years. Because when we say level 4, maybe when the time comes, I think they will dissect it into yet another level, level 4.1, 4.2, 4.3, 4.4, because they have to kind of develop the marketing tools for themselves to be able to sell it. But anyway, somewhere around 3, 4, we should be able to see it. And again, government goals and government project, they set their goals simply by listening to the public's perception, per se. And they set the goal, and they want to kind of put an air on their shoulders, right? So they're very, very aggressive without really, without carefully considering the industrial standards or industrial progress or whatnot. But, as I mentioned, that's something that we should take advantage of, all right? Why don't we just try our technologies with their goals? And if we don't meet, we don't meet, all right? So I love government policy in that sense, but if you want me to tell you that we're going to meet that goal or not, I'm not going to bet on it, not even $1.
Fair enough. Dr. Yoon, I'm guessing you're going to be very skeptical of the goal, but just in case, to confirm your view on the Korean government target.
Okay, well, very skeptical, of course, and we don't want to listen to politicians too closely when it comes to forecasts about the future, especially if it's well beyond their term. Okay, so yeah, I think he's giving some kind of a vision for what we would like to do. So achieving leadership or being in the leaders pack as far as AV development is concerned, that would be very nice. We don't want to be the first one to implement, I don't think, but we want to be right near the leader so that when new things are being developed, we're in the discussions and able to play an important role in the development.
Thank you very much. Mr. Kim, do you have any view?
I have to be very diplomatic. So.
Can I ask Maha and others here a question about smart cities and connectivity and so on? Does it make, with AV, we've discussed levels 1, 2, 3, 4, and 5. And with smart cities, are there anything similar so that we can judge the smartness of a city? Or does it make sense to even have these levels of smartness for cities?
Wow.
In my opinion, I don't think you can gauge the smartness of a city. It's a metaphor that you're using because you have multiple factors. You have IoT sensors, you have infrastructure components, you have cell phones that people are using, you have the autonomous vehicle, maybe aerial drones and so forth. I think it's going to be very, very difficult. I think one way to gauge, in my opinion, the success of a smart city is the consumer adoption. If you see more and more people are using edge services, forget about where are they using it, especially if they are being transported from one area to another, if they are on their cell phone or they are on that hub inside the car, like I showed you in that video. Student is doing its homework, the other one playing games. Once you start seeing money being made from these edge services, then you are successful. This is how I gauge it. It's the consumer adoption.
Yeah, and the reason I ask is because it seems like anyone can put a label like Elon Musk with his cars and say we have a smart city. And I've been in many countries around the world where they claim smartness, but I couldn't find it anywhere. Yeah, really hard to do.
I fully agree. And that's why the first slide with Elon Musk was truth. You have to tell the consumer the truth, right? But I will tell you, have you been in a fully autonomous or fully automated manufacturing facility, especially in car production? Did you see how these robots, they build these cars? they get close to each other by less than a centimeter and they don't collide.
Right.
See, this is where you can see that it is possible to do it. But in a fully automated manufacturing entity, you have robots everywhere. You barely see any, manufacturing people between these robots, and that's why they work flawlessly. So to get to that with autonomous, it's going to take time because you're always going to have the hybrid ADAS and AV running on the streets. But definitely we can get there. So I am very, very hopeful, and I think smartest is gauged, in my opinion, in a city, especially in Korea, is when the consumer takes these vehicles, use the services, and provide positive feedbacks.
Thank you. Maybe this is also a good opportunity to remind our audience that they can, our online audience, that they can submit questions online. So we will try to save some time to ask those questions, including from the floor as well. On my side, I can't see any online questions right now, so I'll continue. But if you may have any questions, please feel free to submit it in the Q&A chat, or if from the floor, if Dr. Yoon or Professor Choi can let me know, then we can definitely give an opportunity to the audience to ask as well. So while we await questions from the audience, if I may continue this discussion, and Dr. Choi, if I understand correctly, essentially the market over the next couple of years is going to be about sensors for ADAS, at least as far as the passenger vehicle market is concerned. When we look at ADAS, and then when we look at the requirements for level 4 autonomy, is it fair to assume that by deploying more and more vehicles with ADAS or with level 2 or level 2 plus or level 3 as some of the newer models are considered, can the learnings from those help us to sort of evolve towards level 4? Or are we, so is it sort of like a evolutionary step, or is getting to level 4 really about having sort of a revolutionary breakthroughs in the technology side?
Yeah, I think this is an excellent question. I believe in gradual evolution, then kind of disruption of evolution. So definitely, I think the more miles you accumulate, learning miles you accumulate, and that's something that Tesla's doing with all its cars. So if you compare Tesla to Cruise and Waymo, they have more data than both of them because they collect data from all these cars, and they already set the stage for the number of sensors. So increasing the number of sensors just makes it easier for them. They started with the lowest number of sensors to see if they make it happen. So all what it takes is you can add more sensor, maybe add more radar on the side or in the back, or probably add more camera, or maybe even a LiDAR. I don't know if they ever put a LiDAR, but it just makes it easier. And compared to an autonomous vehicle that starts with a very high number of sensor and then start gradually to reduce it, I think this is not going to happen. So definitely, I believe in evolutionary learning, and it's very similar to the human brain. When you start driving, you're always very nervous, and then a few years, especially you're driving over the same road, it becomes very natural. You don't even feel it until you get home. So it's going to be very, very similar to the human brain as you train these software stack. And that's why you see, as I mentioned, a lot of companies getting into the mobility, because today we have cell phones, tomorrow is going to be your car.
Very nice with that visualization. Just wanted to check, are there any questions from the floor?
Hello. I have a question.
Yes. Please, yes.
Yes, it's been very interesting discussions about smart city, especially on the Sejong smart city. And I have a question for Mr. Kim.
If you could please introduce yourself as well.
Oh yeah, I'm Erica Oh.
You can take your mask off.
Hi, Ali. Yes. I have a question about the Sejong Smart City, especially on the schedule. Before coming to this forum, I have glanced through some of the articles relating to the development of Sejong Smart City and what the schedule is like and who's involved and all that stuff. And it seems that the schedule has been, kept being pushed back. I think the inception of the project's been like sometime around 2018, and then the schedule's been delayed until like 2021, which is this year, and then it's going to be delayed until like 2023 and 2026. So I wonder what the main problem is, and Mr. Kim has just mentioned also that they are considering to have multiple lanes for the AVs, towards the center of the road, and then they have different roads for different types of vehicles. That means that the blueprint of the roads, the city is not being established even as of now. So I wonder, since he's the insider of the project, it's the closest person I know so far, as an insider, what is going on with the Sejong Smart City, and what's the most realistic schedule ahead of us, and who's going to move into the smart city, and have they considered to have the car owners already, who have their own cars and who want to use the cars instead of the AVs, the new ones, because it's not been tested yet, right? So how can you address all the problems, all the issues so far?
Okay. So to understand how Sejong and Busan is structuralized is those projects are a little bit different with the normal development project. Company like LG, they are making a consortium, and they also invest themselves. They invest their budget and the manpower to make this city together with the government budget. So to do that, they have to make a special purpose company for development. Normal development projects always have this SPC structure, such as when we build a new road, when we build a new bridge, there's always SPC structure comes, and they are maintain the city. Sejong and Busan adapted this model, so Sejong and Busan, LG and consortium will maintain and providing services for next 10 to 15 years. So that's the business model for Sejong. And that's why LG is highly interested about it. And when you question about schedule, for us, 1 or 2 years is not important. Our timeline is 15 years, because a company like LG, and they can only see the business model with the providing services and having users for next 10 to 15 years. So current stage is we are making an SPC at the moment. This SPC will maintain all the services and for the smart city. But at the same time, we are trying to make this service model globally, looking for the other project in the globally, so we can do this pilot project together. But you will see very feasible, tangible things from the end of this year, because next 2 to 3 years, we have to start the pilot project in Sejong. That will lead the whole project in Sejong. It's the same structure for the Busan. So next 2 to 3 years is very important for the LG smart city, because these 2 to 3 years, we have to make all the scenarios. We have to persuade the people. We have to talk with the people how this will be adapted in the smart city. And you actually mentioned one of the main issues that we are having now is also this car issue, car restriction zone. Sejong must follow the no car zone in the city, inside the city. This is a little bit difficult topic, because we have to change people's behavior You can't change normal people's behavior as a company perspective, but so that's why we're trying to provide the best service model there, so you don't need a car. We can't say you drive your car, you pay fine in here. We can't do that. So we have to provide them a perfect service model, so you don't need the actual car to do that. So the 8-road system is one of the main road that we are making it. But other things, we have a very different service-based strategies how we can make a road and let other vehicles driving. We're also considering air vehicle as well, how to make it possible. But next, as I mentioned, people 2 to 3 years, how to make a pilot project, how to accept with the application company is very important because this will design whole the service model for Sejong. I don't know if it will answer your question. Am I answer all the question, Erica, or is there anything, should I answer more?
Not all, but I have a little bit better picture now.
Thank you.
Thank you.
Thank you very much. Actually, I would like to invite Mr. Jung Kwang Kim to ask his question, a very interesting question around the ecosystem for AVs. Mr. Kim? Or if there are any technical difficulties, I'll ask the question on his behalf. So the question is around, as AV developers become stronger, particularly system integrators like LG CNS, how do we see the ecosystem in a future smart city evolve? Is it going to be similar to how, for example, today in Korea on the telecom carrier side, like we've got 3 companies dominating? Do we expect that in the future, mobility in a smart city will be dominated by 2 or 3 companies? Or is it going to be more similar to what we have now? So who will be really the winners and the losers of the future?
Oh yeah, that's a very difficult question, yeah? Well, for the Sejong Smart City, we are also working with the telecom company because 5G connection is most important. But as I tried to briefly explain our strategies, it all depends on service model. So we have to maintain the city 10 to 15 years. So AV will also, we might require different types of AV in next 10 years, or maybe next 5 years, 2026, we need it this time. So this have to work together with the other different application company, because LG is not providing any application, LG is providing a platform, but we are looking forward to working with the other application company. So I can't say some company can dominate the service because it will divide with the many different sectors. And also it depends on which services we are actually using for the AV. So either it will be the delivery, last mile delivery, or either it will be the last mile sending. I don't know what's the best way, but yeah, I can't say it will be dominated by some company.
Thank you, Mr. Kim. And we are unfortunately running out of time, so I'm going to quickly give an opportunity to the rest of our panelists to, if they want to answer this question, as well as share their last remarks, starting with Professor Choi.
I don't think I know the answers, because I don't think, in terms of smart city areas, I don't see any one dominating player is going to be there, because constructions, it's 5,000 history is there when it comes to construction. But this smart city constructions, it will also require a lot of players to complete the whole system. So I don't see any dominating players going to be there. A lot of people have to work together. That's my view, yeah.
Dr. Yoon?
I agree with Dan. That's it. Yeah.
Thank you very much. And Dr. Ashur, you get the last word.
Yeah, I want to thank you all. This is a great discussion. I think sometimes the mobility sector, especially car OEMs, they're so focused on autonomous vehicle, they miss the global picture that actually it does take a smart infrastructure to make it happen. So I'm very happy, Ali, that you led this excellent panel to cover all of these different holes and paint a much concrete picture, especially if Sonju City wants to make this happen the next 3 years. Good luck. Hopefully one day I'll go to Korea and I'll see it with my own eyes. I'm a big promoter of autonomous vehicle for a very good reason. I have a daughter who's a professor at Stanford. She never drove a car. She realized, yeah, well, it's because she wants to be on her cell phone the whole time. So it's very important that I see her being driven safely from one point to another. Lyft and Uber drivers are not going to be as safe as Cruise and Waymos. That's very clear.
Cool.
Thank you very much, Dr. Ashur, and thank you very much, Dr. Yun, Mr. So Kim, and Mr. Choi, and I'll hand it back to Mr. Choi. Thank you very much.
Okay, thank you. Thank you very much for your service, Ali. Thank you very much for your participation, Maha. Thank you.
My
Okay,
pleasure.
now it's time to ask Chairman K.H. Moon to give us a closing remark for the first session of today's event. All right?
Thank you.
Please.
Thank you, Professor Chair. Thank you, Professor Chair. You have done excellent job. And Dr. Maha Ashur, you did excellent job. You converted many people into believer of next generation technology, including So Kim from LG and myself. Of course, you also produce many skeptical leaders, including Eugene Nguyen. But I think it's like the time around 1 decade ago when we had a controversial topics around electric vehicle. But 10 years later now, you know, it became a mainstream. I think you need some support up until you reach some tipping point like electric vehicle. I think you need a subsidy, like the subsidy on battery, subsidy on R&D, and several others. I think your radar system or other system, including infrastructure, might require the similar level of a subsidy from the government, subsidy or fund from the venture capitals to accelerate this transformation and to reach your tipping point. So I strongly propose to have some ongoing community of participants who will work on this kind of this mechanism or accelerator, which will facilitate and accelerate this transformation in a shorter period. When you consider over 20,000 people being killed in the United States alone by car accident, I think this autonomous transportation system, autonomous vehicle can be justified in a much earlier days and in an accelerate mode. And I strongly recommend Chairman Kang to join this community of participants, and I hope he to realize his dream on level 2.5 buses and level 4 buses in next 5 years with your support. And I believe Korean government is relatively similar to my style, a little adventurous and taking some meaningful risk compared to other countries. And I believe Korea could be your best partner in terms of developing this next generation technology acceptable to the average people, but at the same time inspiring the people who are really expecting some improvement in this area so that city to be safer and sustainable, and also bring a lot of new life to the people who couldn't drive by themselves. In my case, I'm heavily relying on this auto driving system, even though those are level 2, level 3 level, but still I'm enjoying that very much, especially to keep in line in the tunnel and many other areas. So I wish you to continue your effort and keep close contact with the Korean partners, including Chairman Gang of Edison Motors. And I hope his Edison Motors are equipped with more radars than Tesla. And Chairman Gang wouldn't save costs on the radar because he strongly supports the safety among any other things. So you'll find a very good partner at their side, especially on bus. So let's meet on October 29th Korean time and October 28th Silicon Valley Standard Time. That is the first day for our community of participants, focusing on autonomous vehicle and inviting bus manufacturer. Is it okay, Dr. Maha Ashur?
Yeah, sure, definitely.
So thank you very much for your active participation for whole morning, including Dr. Asama and the chairman of Alice and Brent McDonald and Chairman Gang and all the moderator and panelists. Without you, we couldn't be exciting as much as now, and your discussion inspired us all. And have a good day, and tomorrow morning we will start with day 2, focusing on startup ecosystem, encouraging this kind of new technology and inviting these funds from venture capitals and also inviting new policy from the government. And as well, we will encourage Korean university to work together with the university in the United States with the discussion tomorrow. And see you tomorrow. Thank you very much.
Thank you. Thank you for giving us a great closing remarks, Chairman Moon. So this is the end of the first day of 3rd Silicon Valley Business Forum. Farewell. Good night. It's not morning out there, right? Okay, good rest. And good day to everybody in Jeju and Seoul, Korea. All right? So long. Oh, one thing for sure is you will be welcomed when you visit sometime soon. That's for sure.
Thank you.
All right?
Thank you.
Bye now.
Bye.
Bye-bye.